So we're back, right? We're back. And for the first time, we have something not so common that we do on Tech Days. We usually have one presenter, maximum two, but today we have like, I don't know how many people on stage, and Agla gonna introduce them and just take it away and enjoy.
Thank you. So, hi everyone, I'm Agla from Nord Security's legal privacy team, and welcome to our special privacy session powered by Nord and Surfshark privacy legal teams. Thank you all for being here. Thanks to the organizers for inviting us. We have little time and a lot to discuss today. Surely you have heard of the GDPR, European General Data Protection Regulation. This is the main legal act who truly changed the game of data protection worldwide. GDPR came into force on 25th of May, so tomorrow it will celebrate its 6th birthday. GDPR is thankful for the applause, and that's why we decided to mark this May as Privacy Awareness Month at Nord and Surfshark. So it's a good time to think and to discuss how we process personal data at our companies. And today's special privacy session is dedicated to privacy nightmares, data breaches. And I want to highlight that dealing with data breaches is a team effort. It's not only up to IT or InfoSec to manage them. Everybody has to play its part, from legal to PR and beyond. Only acting together, we can prevent them at the first place, and if something happens, solve them, manage them efficiently. And to tackle the data breaches from different perspectives, today we have some great panelists joining the panel. Algirdas Šakys,
hey everyone.
SOC team lead at Nord Security, Miguel Fornes, Chief Security Officer at Surfshark.
Good afternoon, everyone.
Laura Tirilite, Head of Public Relations at Nord Security. And Thomas Sinitsky, Managing Director at Nord Protect, a brand new product in the Nord family. Yet. So let's get it started. And personal data breach. Before talking about personal data breaches, we should be in sync what personal data is. I'm sure you all did the privacy online training we prepared for you, but just to remind, personal data is an information that can directly or indirectly identify an individual. This means almost every information about the person, not only their name or email address, but also more sophisticated elements like IP address, location data, user ID, subscription details, logs, and many more. And when personal data is affected, this might be a data breach. So my first question goes to Miguel. Miguel, could you explain how to identify a data breach and set out the key differences between a security incident and a data breach?
Well, I think that first, the most important thing to discuss is that data security is a rather complex topic. And, well, ISO 27001, which is one of the most important information security standards in the world, defines a security incident as the event or series of events that may endanger the confidentiality, integrity, and availability of the information or systems, which is already quite a mouthful, So let's try to make it simpler, and let's imagine your computer or your server as your house. And the information you keep in your computer is the belongings in your house. So what is a security incident in this example? Well, you are calmly in home, and you are hearing a cracking sound in the middle of the night. Or you notice that a window is open when it shouldn't be, and you remember that it wasn't open. Or you are arriving after shopping, and you see that the lock looks funny. You know, you feel that something is odd. So that is a security incident. It's not the fact, but you have to investigate and you have to swiftly take action into it to understand what's going on. Whereas a data breach, a breach itself is the fact that you realize that, okay, something inside my house, something in home is gone. The money is gone, the TV or something, some of your valuables are actually gone. That is the fact, that is the data breach. So, a data breach, a security incident, initially is handled, and when it's actually confirmed, then we are talking about a security breach. We have a number of a wide spectrum on what different security breaches you may have, and personal data breach is just a subset of that wide range. The thing is that typically what we consider as the quintessential personal data breach is just simply those ones that affects simply the confidentiality of the data. The typical thing is, a lot of data is simply out there, but quite often the data breaches that affects integrity or availability of the data are heavily overlooked. And examples of data breach, including all of them, the typical, also really the most noticeable one is the destruction of data. Right now, since the horrible war against Ukraine, we have seen a surge on cases of wipers, which is a particular set of malware whose intention is simply to wipe everything on the server. They just simply try to harm any type of service or company by simply deleting all the data, including personal data. Then we have data loss that, it might be similar to the previous one, but at least it's recoverable. We can do some effort. It may take some time to recover it, but at least it's not totally destroyed. Example of this will be, your laptop ended up in the bottom of the lake. Big deal. But with a little bit of luck, maybe there's a backup on Google Drive and we can recover it. Also a server that is crashed. Somebody made the wrong thing on the server is crashed, it's deleted. With a little bit of luck, the IT team or different teams will be able to recover that data and put it back to work. Then we have alteration, which is the impact against the integrity of the data. Alteration sounds very boring, but just imagine that in a governmental platform, Smart ID for these people, for us in Lithuania, just 2 numbers of your ID are swapped. Just that. Imagine how much headache will that create to you. It's an example of integrity. And then we have the typical ones, the most famous, which are the unauthorized disclosure and unauthorized access. The perfect case of hacking. Somebody broke in the server, somebody broke into your computer, and either access the data irresponsibly or simply it was totally leaked. Those two, usually they are coming hand by hand, and the so famous data leaks, massive data leaks of Facebook and platforms like that are falling into this particular type.
Okay, thank you, Miguel. So let's remember, every security incident is a data breach, but not every data breach is a security incident. Of course, the company has to address every security incident properly, but when it's a data breach, additional duties under the GDPR arise. We will speak about them later. And surely you heard a lot of cases about the companies suffering data breaches. A few days ago, a news broke, Google Cloud accidentally deletes a huge Australian pension fund. Data destruction might be considered a data breach. Our competitors were also affected. For example, some VPN services were involved in a data breach, which led to exposure of more than 20 million users' personal data, emails, passwords, payments information. LastPass, our NordPass's competitor, suffered a data breach in 2022. Corporate and customer data was stolen by hacking an employee's personal computer and installing a keylock malware with access to company's cloud storage. And many, many others. For example, at the beginning of this year, a so-called mother of all breaches was discovered, a database containing more than 26 billion records compiled from LinkedIn, Twitter, Adobe, and thousands of other companies. Facebook suffered multiple data breaches. In 2022, more than 500 million users affected due to data scraping, seizing, and unpatched vulnerability. Just 3 years before, Facebook had another data breach, 400 million users, due to a misconfiguration of some databases. In 2017, Yahoo, 3 billion users affected. LinkedIn, in 2021, 700 million users affected, data stolen by using data scraping techniques and exploiting the site's API. So there are lots of famous cases. Last week, Netflix released a new docu-series about Ashley Madison, an online dating platform for cheating husbands and wives. If you haven't watched it, please watch an interesting story about the hacking of 32 million users, sensitive and secret data, and it caused a lot of chaos and huge media frenzy. So when it's a data breach, we must be sure we have to act fast. If there's a risk to individuals, we are obliged to notify the Data Protection Authority. We have only 72 hours after becoming aware of the data breach, so immediate attention is crucial. Now we'll speak about the procedures, how to manage data breaches. Nord is adopting a new breach management procedure. It is part of the security incident management procedure. Main handler of security incidents at Nord is Algirdas. So Algirdas, could you please highlight how data breaches are managed?
Yeah, as you mentioned about procedures, so procedures are already aligned and we have all the procedures matched. So our incident response procedure process is aligned with data breach process. And what is changing when we try to adopt this and to align this? So basically we are focusing more on the data, what we should collect. So GDPRs and organizations that ask to report us about data breaches is asking more information, what had happened during those data breaches. So actually what we're trying to get is what is the type of incident? As Miguel told us, is it a loss of availability? Is it a loss of integrity? Is it a loss of confidentiality? Maybe we cannot, maybe our users cannot connect to his NordPass item vault. Maybe there is no data in Nord account related to this user. So we are trying to understand what is type of a breach. We are trying to know, is it malicious actions or is it non-malicious actions? And actually, oftenly it is non-malicious actions, and we as users, data users, are often leaking that data to some third parties, and it is unintentional. We don't want to leak that. And mostly we are facing with those data breaches, and the malicious ones are a bit rare, what we are seeing in our cyberspace. What is next? What we want to understand? How many data subjects are affected? Are they our customers? Are they our internal employees? What is the volume of data breach? we want to gather this information to provide such information to our privacy team so that they can have the most, they could have the best decision made to notify our customers, to notify our employees, maybe to notify our regulation organization. So yeah, we should provide more information during those data breaches when we are comparing to the regular incident that we are managing on our cyberspace.
Okay, so Miguel, when a data breach is identified, what are the first immediate steps that we should take?
Well, first and most important is the detection. Without detection, nothing actually will work. And for detection, we need actually the active input of all our employees. Because yes, we have platforms, we have systems, we have extremely qualified professionals that are taking care of a lot of things, but it's not the same 3,000 people than just simply one or two teams. So rapid response is the key point, and this responsibility falls in the shoulders of all of us. I mean, and I mean saying each and every of you, please report. Report is the most important part of the incident management. We cannot act against something that we haven't seen, and it's way better to receive 17 or 300 false positives that just simply miss a real positive. So after the detection, well, there's a number of things that happens on the background. There's a lot of efforts regarding the initial diagnostics, the identification, the triage. We need to categorize what actually happened. We need to understand how many records were affected, exactly what just Algirda said. But I believe that the most important part is the what everybody knows as response. We need to recover. We need to stop the bleeding. What happens? We need to simply try to put a plaster to avoid that we will choke, stop the bleeding. Well, typical actions in this case will be simple things as isolate the devices that are actually suspected to be involved on the incident. We are simply removing them from the network. We are revoking access and credentials that are suspicious to be related to that. We are reviewing if the programs that actually the program itself uses credentials. We need to block and to understand what happens with those technical users. Also, we may simply review rules of on the firewall on cloud-based services like Cloudflare. Also, we should, and we typically will review the rules and accesses on the data loss prevention systems. A number of things that are actually happening quite fast and quite in parallel, but those are the things that are helping to stop the bleeding. Isolate, try to contain, and revoke accesses that are actually feeling minimally funny. And aside that, also one of the most important things is backups. Sounds like quite simple, but one of the most important processes to recover the data is simply restoring the backup. So,
okay, so hashtag stop the bleeding.
Stop the bleeding, absolutely stop the bleeding.
And hashtag 2, assess the severity and, if needed, notify the authority and the affected individuals. So when the breach becomes public, the general public might be curious and waiting for some answers. And PR plays a crucial role to get a great positive or a negative attitude about the company. So Laura, can you describe the first steps taken by the PR team when a potential breach or a breach is discovered, confirmed? What's going on then?
Yeah, actually, it was a bit of a wrong, question. The reality, the sad reality, is that when data breach goes public, as a PR team, we can try, doing our best and to diminish it, but we won't eliminate it. So when it's in the media, it is already in the media, and it will do some kind of impact for the perception about the company, about the reputation, about the products, and etc. So I would say that the worst case scenario for us as PR professionals is when information about the data breach comes from a third party and company stays silent and doesn't have the answer for a very, very long time. Because what happens is that through that time, because information vacuum, it doesn't exist. Like there's no such thing. So it means that while we are silent, other experts, journalists, our customers, or whatever who so said experts, they're starting to spread their opinions, perceptions about what happened, why it happened, and etc. And then for us to fight those opinions, it might be very, very difficult. So one of the most important things I would say when a data breach goes public is for communication, security, risk, tech departments to cooperate very closely and to provide some kind of statement as soon as possible. I would say my dream is in an hour or quicker, but I know that from technical standpoint, sometimes it is very difficult to determine exact scope of the data breach and also to understand, you know, the source of the data breach. But the first statement, it can be very simple and not technical, just to establish that, you know, yes, we're aware of that, we're working on this, we're investigating. Maybe even say that at that point we still feel that, you know, our users can use our tool and be pretty safe.
So can Thomas applause?
I want to clap.
Can,
And I
so can a data breach destroy company's reputation? How long does the audience remember?
Oh, definitely it can. Perhaps there are very few cases in the world when actually data breach ended up with the company, you know, completely bankrupting and etc. But usually it really takes time. The initial phase of the, well, it's a communication crisis already when it is out in, you know, in the media. So initial stage of the crisis, it usually takes around a week or something, but damage control can take more than a year. And I would say perhaps quite a few of you remember Nord's security incident that happened in 2019. Even though it was minor, it didn't include any personal data, so it was not data breach. It was just an incident. But till this day, still some reviews mention it, and people, you know, you can still find information about that, and etc. The other point is that when we are thinking about data breach, it's not just reputation that we should consider, but also data breach can, you know, destroy some business processes or, you know, revenues or something. For example, you mentioned LastPass's data breach that happened, well, pretty recently, let's say. So if you look into Google Trends and LastPass data breach, at the same time when the news went out into the media, what we see, there's a spike in searches for 1Password and Dashlane. So it means that users were actually looking for, looking into competitors and, you know, maybe perhaps even switching their password manager.
Okay, thank you, Laura. So what should we do to prevent data breaches? Preventive measures are crucial, mitigating the risks. And it's essential that every department plays its role. So next question goes to Thomas. Applause.
typically they applaud afterwards. But
They can applaud afterwards too. Thomas, you're orchestrating the launch of a new Nord's product, Nord Protect, which involves different identity protection features. And from a product development standpoint, how do you incorporate privacy and security to prevent possible data breaches?
Actually, thank you for excellent answers. And I just realized that I don't have a security manager on my team, and I don't know where to report those incidents. So yeah, we're still maybe 6 months away from the actual launch, but this has already been valuable, so thank you very much. I think from the product development perspective, the key thing is perhaps to stay humble and not assume that you know everything. So my approach, at least in my team, is to go and ask people who know stuff to help me out. So first of all, I mean, you have to get other teams and units involved to kind of guide you through, you know, the jungle of laws and regulations, and also the processes of how you manage, you know, incidents and problems when they arise. So luckily enough, you know, there are places to leverage all those competences, right? So the 7th floor in a building where you sit, Lot, it's a good place to start. So so we started there, because you see, every product designer or every product manager doesn't know, you know, all the twists and turns and latest and greatest regulations, and you do know that. So go and ask them and comply with that. So that's number one. And that probably prevents, it doesn't necessarily eliminate the risk of, you know, a data leak or breach or something like that, but at least it possibly eliminates the risk of getting fined. And if we are getting fined, then Laura has to work, and Laura is a good friend. You don't want her to suffer, so so you go to legal first.
You let legal suffer.
Not suffer, work. And work is very rewarding. Nothing works as hard as legal department. Applause. Now, I wanted to say on a more serious note, but that was serious, even though I was asking for. I live for the applause, actually. So,
Applause.
in the particular case of Nord Protect, we are a unique product in you know, in the making, in that, you know, we are not a software product. We're not an infrastructure product, right? This is how it is different from your typical Nord family product, right? So we are basically going to offer a combination of third-party services, which means that we integrate with third parties, we combine their services into a single or multiple propositions, and then we sell it to the market, right? What that means is you have to pay attention to your vendors, right, to your partners. So luckily enough, in this company, I don't know anything, but we have a chief risk officer, and his department has a vendor assessment methodology. You go, which floor are you sitting on? 3rd. You go to the 3rd floor. You ask them how to do it, and then you apply your common sense and whatever research you can do on the market, and choose the most reliable partner you can choose from. And this is actually a real story. When I joined the company, we were very close to signing with a vendor that it turned out later was only like of the size of 12 people somewhere in California, and developers were spread around the world. And we kind of, luckily enough, we found that out and decided not to do it. And now we will engage with, you know, publicly listed companies, etc., etc. I will use up all the time. And the third thing, which is which I think we are very good at, that it's obviously technical measures, right? So I think the secure software development lifecycle implementation at the company is you know, is making a big impact. And look, I'm not a technical guy, so I tend to go to information security people, and Marius Bried is here to help us out, figure that out. And I think the key thing is, as I said at the beginning, staying humble, curious, and relying on other people that are experts in those fields. And yeah,
Okay.
being risk averse helps. And I know that you wanted to ask one more question, right?
No.
You wanted?
No,
Okay.
it's a question to Algirdas, following up. And Algirdas, do we have best practices, or are there the best practices in the world? How built-in features help to resist a data breach?
So I think I want to talk more about preventive controls what we have already deployed in our infrastructure. So basically we have firewalls, we have EDRs, and I think everyone noticed that we are changing from one EDR to another EDR, and those preventive controls helps us to detect something what is happening, to detect threats, and to respond to those threats. And actually, what else we should agree that we should also take attention to administrative controls that Agla was mentioning about training, awareness training, about where to report about security incident, data breaches, what you are feeling, what is happening not in the right position. Also remembers to have secure passwords, use password managers, and etc. So when we are talking about the privacy, and the most crucial thing, I guess, is that we have to minimize the personal data that we have on our laptops, on our systems. We don't need trousers, as Miguel said before when we talked. So you don't need that information about the employee, you don't need about the customer that information. So yeah, the power of minimizing the data that we collect is the most crucial thing.
Okay, thank you. So in 2 sentences, Thomas, how do you balance product safety and product development? You have to bring the product to life.
You mean do you when you have a deadline and the CEO is shouting at you and
Yeah.
your security is
And
not in
we're
place, what do you
already
do?
out of time. Let's
Yeah.
be quick.
In my case, I don't compromise security, for the sake of a quicker launch, and I think it's logical because it's just the risk is so big that it's not worth it, right? We are probably going to be a billion-dollar company soon, and if we are, applause.
Applause.
So any new initiative is not, any new initiative is not worth the risk of putting your, of jeopardizing potentially, the well-being of 3,000 people, or I don't know how many we have right now, and many of their families. So at least my approach is never, never compromise security and safety over, 3 months. Quicker launch of a 3-month period or something like that. Thank you.
I
It
think
was
this
a very good
deserves
question
an
and an even
applause.
better answer.
Yeah, so dear panelists, thank you for your insights and this engaging discussion. And I hope it helps to all of us be proactive guardians of privacy and personal data. So stay curious, stay alert, and do not hesitate to contact us if you have further questions.
Yo, beautiful people. Hello to NordTech. Tech Days. So I'm really happy to be here again on the stage. I hope you missed me already from the last year. Hello to all the people that gathered here in the Švitrigailos 36 in Vilnius. Hello to all the people who are watching us online. I hope you're having a great time while working and watching Tech Days. What I want to express today that we have the speakers from NordVPN, NordPass, Layer, and we have even a special speaker that came from Netherlands to talk a little bit about quantum computing and, I don't know, wooden sticks. I don't know what the hell gonna be that, but we are waiting for this. What else? It's the 6th event of NordTech Days, and I don't know if Evelina knows it already, but the next one we're gonna do open, right? Yeah, she's saying that is gonna be okay. So basically, the last private event, we're gonna introduce new people that maybe wanna join and to do some kind of a speaking here. Before going into that, my name is Marius. I don't know if you know me. I'm the CTO of SAT Infrastructure. And we're going to talk a little bit what we're going to have today. So, but before that, if you are not already on the Slack channel, please join NordSec Tech Days. You can find additional info there. You can have questions in the threads for the people who is going to be on stage today. They're gonna answer, maybe live, maybe not, maybe after the speeches that they're gonna have. And today's agenda. We're gonna start with Jakub from NordVPN. He's gonna talk a little bit about optimizing performance and Go, really interesting stuff that we have real case in NordVPN. Then we're gonna go into backend driven UI by Adomas. Adomas somewhere there. Hey, Adomas. We're gonna have a little break. Then Lucas is coming back on stage again. He's gonna represent the WireGuard and how we are using at Nord. Marta is not the first time on the stage as well. Not the first time, right, Marta? No, she's standing that not. Gonna talk a little bit about data science. Then we have some really new stuff. For the first time, we're gonna have a special privacy session because we have a privacy awareness month this month, and we're gonna have like an open discussion that's gonna be a panel some sort. Then we're gonna go into NordVPN's app performance for the Android. A great escape from AVS, how much money we saved. That's a really interesting story. Then we're gonna go into short break, and the second part, going to GitLab and backing to GitLab. That's gonna be interesting, I guess. About fake leads, and we're gonna end up with well, patents. I don't know if it's gonna be a tech one, but I'm gonna present those and how much we have already. And we're gonna have the final session with Andrianus about that within sticks that I mentioned before. So just to remind you, NordSec Tech Days channel, Slack one, join, ask questions in there. If you're gonna have questions live, we have a separate microphone as well. Besides that, the interesting part, we have a quiz. And if you want to have these beautiful t-shirts, there is a possibility to gain them through quiz. So throughout the lunch break, we're gonna have snacks here and 5 questions for the quiz. If you're gonna answer them correctly, you have opportunity to win them. Try, do it. The questions are not hard, not easy. And yeah, you're gonna find various ones in there. And that's it, I guess, from me. I would like to welcome Jakub on stage. He's gonna talk about optimizing scalable performance and stuff. I don't know. Let's check it out. Jakub, take it away.
Okay, so as you can see, my name is Jakub Gargul, and I'm here to make your programs run fast. Basically, let me grade the audience a little first. Which ones of you know what Big O convention for analyzing the algorithmic complexity is? Raise your hands. Come on, if you're an engineer, if you're a programmer and you don't know it, it's not a good sign. But yeah, I'll try to keep it short to not make it an academic lecture. I don't want to bore you too much. Basically, most of you probably know Big O is a convention for analyzing the complexity of algorithms that you use in your programs based on the amount of data you want to process in your algorithms. And the most standard complexity you have is the linear complexity. If you just want to go over the data set that you have in some program, basically the amount of time you need to analyze all your data, if you are doing something like linear search, or if you are looking for information in all of the, let's say, entries in your list you have, this is like box standard of linear complexity. 10,000 elements, 10,000 iterations, nothing super complicated with that. When you go further in the woods, the complexity starts rising, and second one would be quadratic, cubic, and so on complexity. Basically, there are not a lot of algorithms that would exhibit this complexity. Maybe like things like multiplying matrices. From what I remember, it falls between squared and cubic complexity for optimized algorithms. But usually, if you see complexity that's growing quadratically from the amount of data you have, this usually exhibits some problem in your programs. In data set of n, let's say 10,000 elements, if you have a squared complexity for these 10,000 elements, suddenly it becomes 100 million iterations. So usually you don't want algorithms that exhibit this complexity. Third one, probably the most important tool programmers have in their arsenal is logarithmic complexity. We use it in binary searches. We use it in all sorts of trees. sorting is a form of logarithmic complexity where every single element in the list will be compared logarithm times with all other elements. Basically, it's a generalization of divide and conquer algorithms, and it's very useful. Just trust me on this one. There are more complexities that are encountered by programmers every day, but I would try to keep it short. Complexity is like, it's a topic that you can keep diving into, and suddenly you find out that there is not only just big O, because big O gives you the asymptotic upper bound. There is also big theta, big omega. Big theta is sort of average. Big omega is the lowest asymptotic complexity. It's a really deep topic, and I don't want to make it into a lecture, really. The last one I want to talk about is basically the constant complexity, which is accessing known ID in a list of elements. This is what all the modern hash maps use to allow you to see your data in constant lookup time. This doesn't mean this is the fastest, but this is the complexity that requires you to view the least amount of elements. And like I said, in combinatorics, in NP-complete problems, like for example, traveling salesman problem, there are a lot and there are a lot other different complexities that you can encounter. But for general applied programming, what you would want to deal with, what you would want to see would be linear complexity, cubic complexity, squared complexity, constant, and logarithms. For people that don't deal with programming directly, analyzing complexity is also really important, I would say, as far as grading the strength of passwords goes. If you would Google the phrase under the first comic, I didn't include it because the comic is too long, but there is always an relevant XKCD for everything. And basically, this phrase that you see on the bottom shows you how strong your passwords become the longer you make. This basically deals with entropy you introduce into the given password, and basically you want longer passwords, you don't want more complicated passwords. And for all of this stuff, there is a good cheat sheet on the internet. Usually someone already made it before us. There is only one thing I would disagree with the author. I don't know if you can actually see it, but there is this line in the middle in the brown area. It's called the bad algorithm. I wouldn't agree with it that it's a bad algorithm. The complexity written there is ON log n, which is what all sorts of modern sorting algorithms do. And it's not actually a bad complexity. If you can get an algorithm that's running in ON log n time, that's actually a great performance, and you want this. Like basically, if you are sorting anything, you will always go down to ON log n. There are other sorting algorithms, but basically everything today is ON log n, and there is no escaping that. Unless it's a quicksort, which is actually the most used one, which actually has a complexity in big O notation n squared. And like I said, n squared is pretty bad, but quicksort is kind of like, usually it's good. So in big theta notation, it would be theta n log n. In big O notation, programmers usually kind of lie, and when they mean big O notation, they don't actually mean big O, because in big O, quicksort would be really bad, but everyone uses quicksort today to sort their data. But yeah, enough of this theory. In NordVPN, we had this project. We still have it. It's called Nord Website Monitoring. Fundamentally, really simple. All it does is basically checking website availability behind the VPN. If user is able to access websites through our servers, through NordVPN, and if we need to do some clever rerouting, masquerading, or whatever that would allow us to see the websites even though they don't themselves want to be accessed through the VPN. Like I said, project is fundamentally really simple. The only kind of complex thing would be that we might have tens of thousands of hosts in every country that we need to check, and maybe every server will have a few IPs to check them from. The program shouldn't have problems, but it was actually struggling a lot with performance and stability, and we don't want that, obviously. Some of these problems were a bit hidden because of the way scaling comes into play with Nord Website Monitoring. It wasn't designed as a scalable service, but basically because every single country will have sort of different kind of list of hosts that we need to access. Organically, Nord Website Monitoring became a horizontally scalable service, where horizontal scaling is basically adding more nodes to your computing power. It wasn't the case of vertical scaling. And in case of these algorithms that I mentioned, in case of these algorithms that exhibit not the most performant, not the most optimal way to process your data, if you do horizontal scaling, it can mask your problems for a little while. Because if you had a machine that had a linearly growing power, and you were adding linear amount of data to it, if your algorithms are problematic and they exhibit O(n) squared performance, then if you added 2 times the data, you wouldn't be able to run this program anymore. With horizontal scaling, it's kind of like you have smaller data sets all over the place. So for some time, this will sort of work. It won't go down crashing as it started happening lately with Nord Website Monitoring. Basically, what we would see was that Nord Website Monitoring would take 1 hour to start up, to generate 100,000 what we would call tasks. Task is basically like host times IP. Every task is basically checking if the website is accessible from the given IP on the server. And if you divide 1 hour by 100,000, it gives you roughly 36 milliseconds, which for parsing an address and spawning a Go routine for it, that's, let me just tell you that it's too big of a number. 36 milliseconds would be too much to look up things, even on a hard drive, and our servers aren't running on hard drives. So why was this program unstable, and why was it actually using so much memory? Because from what I remember, some instances of Nord Website Monitoring were using up to 500 megabytes, which is not a lot, sure. But if you multiply it by the amounts of server, multiply it by everything we're running, it suddenly becomes quite a lot of memory, and for memory, we are paying. So what can you do? Programmers have a lot of tools at their disposal. Flame charts, profiling. Basically, we have a lot of tools today to grade the performance of our programs. Since Nord Website Monitoring was written in Golang, I used a box standard thing called pprof. It's a tool built into Golang, and it gave me a call stack for the entire program. And I don't know if you can see these highlighted parts, but basically, there is one very suspicious part. In external library called GoCron, which we used for scheduling inside Nord Website Monitoring, there is a method called find jobs by tag. And it takes cumulatively 95% of the time in a test case designed just to generate the tasks that we are running on the server. 95% just in a search method, that's something you really don't want. So that's the first place to start looking into. And if you can see going upwards into the call stack on the left side is the unoptimized version. The program spends a lot of time also verifying the method hashtags. So there is some unoptimized path in the program that it's spending a lot of time finding these tags and comparing them. And why isn't doing it? It's really something that I started analyzing. And the conclusion that you kind of reach at some point you really need to know your data. What are these tags? Tags were basically slices of strings, something super simple. First position was the ID of the host we are dealing with, IP, the name of the host, and some other garbage that we don't need to deal with. The problematic part was that find jobs by tag in GoCron was a dumb right down linear search. And linear search in itself, it's not a good search algorithm. But usually you can kind of survive it. The biggest problem was that during the generate tasks, during the task generation, the tasks, which there is n of them, n being, I think, roughly 100,000 of these tasks. For every one of the generated task, method find jobs by tag was generated. So as I've shown you before, every time a task was generated, 100,000 of them, all of the tasks were being searched from to find these tags. And why was it done? Basically, the Nord website monitoring, the generate task algorithm was checking if there were no duplicates generated. And this quickly turned into the squared complexity, into a really bad, unstable program that had trouble dealing with the amount of data that shouldn't be a problem in any modern service that deals with thousands of different data sets. And these tasks, they weren't memory intensive. Like basically, the entire problem was that we were not accessing them in an optimal way. And as for memory saving, it was even simpler to analyze it. Basically, there were ways to shave off memory on every single of these tasks. Like I mentioned in the slide, pass-by value is great. You should love it. But every time you do a copy, remember, you don't want to store that copy. If you store that copy for every single task, like let's say you have 3 different IPs on the server, every task will store the copy of the same target. And with the target, we will have a lot of unnecessary information. Comments, the host name, whatever. Every time you create a task for a different IP and you store a copy, you basically end up with duplicated data and you waste memory on it. You don't want to store copies of your data because the more tasks you create, the more memory you are wasting. And it might seem like that's not a lot. You have 100,000 jobs, you shave off 1 kilobyte on them, but you multiply it by 1,000 server, as you can see, 100 gigabytes, just like that. And there is a big number. That's roughly the amount of CPU, processing time, and memory that was saved just by a few simple things. Changing the amount the tasks are checked for uniqueness instead of stupid linear search. Let's just access them through a hash map. Let's not waste our time comparing everything with itself. There are way better ways to search for your data than doing a dumb linear search. RAM, kind of the same. Like, I didn't even pay too much attention. Just shave off a few kilobytes here, there, shrink your data structures, and suddenly 2 terabytes of RAM have been saved. And the startup now takes 5 seconds instead of 1 hour. How do you want to protect yourself in the future? Documentation matters. You really want to use data structures, you really want to use libraries that document their complexity. If you have a library that doesn't say how much complexity it needs to process your data, usually it's lying, usually it's doing something bad under the hood. And as far as documentation goes, here is an example of great documentation. No, I'm just kidding. Basic string in C++ is absolutely insane. You don't want a documentation like that. But one thing C++ documentation excels at, complexity is listed everywhere. Every single method has listed complexity. You want that. An example from Haskell. Every single method for the list has listed complexity. ON, O1, ON. This is great. Rust. Rust has a great listing of complexity for its collections. If you use libraries and you will deal with a lot of data, you really want your complexity listed. You want to know how much time will you spend just by searching, inserting, popping data from your structures. But all of that I've mentioned so far, it's mostly irrelevant. Because, as Donald Knuth has said, premature optimization is the root of all evil. And the quote actually goes like, programmers spend too much time dealing with little inefficiencies here and there. We should forget about small inefficiencies, say about 97% of the time. Premature optimization is the root of all evil. Yet we should not pass up our opportunities in that critical 3%. So basically, what I'm telling you about this presentation is mostly about the 3% of the cases. You don't care about that. There is a simple measurement I've done for myself on the data structures in C++. And if you can see it, up until 20 elements in any given data structure, it does not matter. You can use anything. You can do linear search. You can do anything. If you are dealing with less than 20 elements, don't overthink it. Don't think about the data structure you will be using. The only moment you actually need to design for it is when you know you will be dealing with a lot of data. You know you will need to actually crunch these numbers. You know you will need to pay attention to the amount of time you spend there. And what I've shown you before was mostly a lie, because these were the dog chart graphs just showing the ideal complexities. These are the real ones that I've run for myself. Don't ask me what is this deep after 100 elements for the linear data structures, because I didn't have enough time to analyze it and I simply don't know. But as you can see, these mostly grow as you would expect. Constant stay constant, logarithm searches, binary searches stay with logarithmic complexity. The linear data structures, they grow linearly. You can observe the kind of difference between the continuous array linear search and linked list linear search, but it's not as radical as a programmer would have expected. Cache coherency, it's nice, but you want nice algorithms, not just cache coherency. For example, the binary search in the tree, the green chart. Tree isn't coherent at all, but it beats a continuous array when you reach any amount of meaningful data. So yeah, what I want to take you away from this, it's pay attention to your data. What are you processing? How can you use it? How to access it uniquely and with good algorithms. Assess the performance, measure it. Don't forget your profiling. You have a lot of tools that you can use for it. Don't overthink it. Don't use data structures in a way that's inconvenient. First, care about what's the more convenient data structure to use, and then start optimizing it, because it will matter in roughly 3% of the cases. And that basically concludes my presentation. Thank you.
So, thank you, Jakub. A really great one. Do we have any questions from the audience? No. I don't think that we have one. I have one for you. What did you learn? What? Sorry?
I said sure.
Ah, okay. What did you learn from this journey? The one thing that most memorable for you?
That I don't like Golang.
Okay, no Go fans in here. Do we have Go fans though in the audience? Oh yeah, we have a lot. So maybe this was a little bit informative for you. What do you like though?
Come again, what did I like?
Yeah, what programming language do you like the most right now?
I'm getting into Rust and it's nice, but maybe you were able to tell that I'm kind of a weirdo C++ fan. There is always like some of these people around.
And we leave you with that. Thank you, Jakub. And yeah, if you're gonna have any more questions, please shoot them in thread on Slack channel. And now we're gonna go into the next one, which is gonna be, yeah, thank you, Jakub. We're gonna be talking about backend driven UI by Adomas, and he is the senior front-end engineer from Notelayer. Have fun.
Okay, so this is a lot scarier than I expected. But anyways, I'm Adomas Liutkus. I'm a senior front engineer at Nord Security, more specifically Nord Layer. And today what we'll be doing is I'm going to step out of my comfort zone a bit because I'm used to giving presentations about various front-end technologies like Vite, like Svelte. And today we're going to be talking about backend-driven UI, which is a very popular practice in mobile application development. But me being a web developer myself, we're going to try and take a view from a web applications perspective. Is this practice something that could be useful? So my experience with backend-driven UI is when I still used to work as a full-stack developer, this is something we used to employ. And to this day, I still think this practice has a lot to offer in terms of making your time to market a lot faster. So let's get right into the agenda. So first, we're going to analyze what problem is this practice solving, because there's a lot of niche software development practices that only serve one specific purpose. And we're going to try and find that purpose of backend-driven UI today, and maybe it's something useful for you and you want to try it. The next thing we'll take a look at is what are we trying to achieve with backend-driven UI, and at what point can we say, okay, this application is backend-driven. Then we're going to go into the pros and the cons, because I'm going to say this right now. This isn't a silver bullet. It does have its use cases, but sometimes it's definitely not worth to go into. And after that, we're going to gather our thoughts, we're going to make some assumptions, and we're going to have a very healthy sanity check in regards to this practice. So we're going to start off with looking at a features development cycle. So I've chosen a very basic one. It involves 6 steps. There could be more, there could be less. It largely depends on your specific setup. But for the sake of this presentation, let's imagine some feature which is very simple. Let's say we have a web page and we want to add a banner at the top of the page that says 10% off, and we want to show it for 7 days. And we should start this feature by gathering the requirements. So maybe we should find the team that is responsible for the scope. Then we can gather all the requirements, and after that, we move into design. So this can be UX UI design. Maybe we have some similar banner that is already present. And this could be architecture design. So let's assume that we are taking a shortcut with this implementation, and we're going to hard code everything in the front end. So we're going to have a static component, we're going to have static data, and we're going to skip out on the backend development part. So naturally, this being a front-end feature, we're going to skip out on the backend development. We'll go straight into front-end development. We developed a feature, we ship it off to testing for our Q&A team. We test it, we see that it's stable, and then we can deploy it. So deployment can be very individual. So for web applications, you can deploy pretty much anytime you want. Us specifically, we have a week-long cycle every time we release. And for mobile applications, this can be a lot trickier because you have to put up your changes for reviews and stuff like that. But now let's imagine we ship the feature, everything is going great. And now we want to iterate over that feature. So now our product owner comes over and says, okay, now we want to show 15% off for 3 days. And at this point, we can start thinking, okay, is this banner something that is going to constantly change? Maybe we should think of a different direction rather than hard coding. So for the sake of this presentation, again, let's assume we landed on a solution that we're going to create an endpoint that's going to give the information that we want to show in the banner. So now this becomes also a backend related feature. So we go into backend development, we develop the endpoint, we ship it off to the front-end developers. The front-end developers call the API method, they get information, they populate the banner with it, and we test it out, we deploy it. And let's say you want to iterate again on the feature. And this time we want to introduce sort of an A and B test. We divide our users into 3 groups, like A, B, C. They receive different discount values. And at this point, what we kind of achieved is we made our banner backend driven. Because at this point, the front end doesn't need to change. It has the basis of having an endpoint which gives the information of what to show in the banner. All the A/B testing stuff can be handled in the backend. And this is going to transition us nicely into what are we actually trying to achieve with backend-driven UI. So this is something I saw on Spotify's presentation about backend-driven UI. And for me, at this point, it really made sense what we're trying to achieve. So we're trying to create user interfaces that are a function of state. So first of all, I think this just sounds cool. And the other part is that it sounds a lot more complicated than it is. So when thinking about state, this word basically gets thrown around a lot. But we can imagine state as just a JSON object that says, okay, we need these kinds of components in our user interface. And this is going to make sense when we look at an example. So on the right-hand side, you see an image. So we have a mobile screen that has 6 components. And these components are described by this state, this JSON object. It has a components array, and each component inside it, it represents some sort of component in the front end. So for the first component, we have a notification component. So based on the type, the front end has the capabilities to say, okay, this will be a notification. We know how to paint this notification, and we know what data this notification needs based on the state provided. If we look at the second component, we have a movie list component. And this is a very similar story. But now let's imagine if we wanted to add another movie list component, let's say below the popular movies. Let's say it was watched movies. To ship this feature, the only thing we would have to do is modify state. The backend is basically ready. If we assume that the whole page's configuration is based on some database configuration. So if we would modify the database, we would get another component inside the state, and our UI would show another component without needing any redeployment. So this goes into our first and the biggest pro of this whole approach is that state is something we can easily modify without redeployment. And this is going to result in you reducing our time to market. And if we skip up to the next point, this also what it does, if we were to create that new component in a web application, that same component is going to render in the mobile applications. Because this state, this isn't something tied to, let's say, a web application. This state can be used for a mobile application, even some other clients. So this is where we start to see really the benefits of backend-driven UI. We can be really flexible, and we can create components inside our user interfaces without needing to wait for, I don't know, Google or Apple to review our changes. And another thing that I noticed in my current workplace of how backend-driven UI can be useful, so we use a lot of feature flags. And feature flags are, I would say, a pretty common practice. And our problems with it is that there are some problems syncing them with the front end and the back end. I'm not going to get into too deep about it. But if we would use backend-driven UI, the front end doesn't necessarily have to even care about the feature flags. The only thing the front end cares about is what state is provided. So if we were to add the same movie list component under a feature flag, the front end doesn't care if that component has appeared because of a feature flag or maybe we just added it. It just reacts to the state that is being sent to it. So yeah, I think removing feature flags from a big part of our system is already a huge improvement, and it can really help simplify our lives. The last thing we're going to touch on is A/B testing. So I kind of hinted at it, but A/B testing is something that requires a lot of flexibility. So we want to allow to write as many A/B tests as possible. We want that flexibility. We want that speed of development. So with A/B testing, you can, I would say, generate an A/B test in one day. You don't even have to redeploy anything. You can just configure some groups, configure the content show for those groups, and you can make assumptions there. And for me, actually, A/B testing started to make sense when I started to look from a backend-driven UI's point of view. And as I said, this isn't a silver bullet. There are still some bad things about backend-driven UI. And they could be, I know, discussed, but we're going to start off with the most obvious one. So this is something that me and my colleagues were talking about, is that it results in a bigger workload for backend developers. And this, by design, is going to be true. Since all the business logic is moved to the backend, then it results in front-enders kind of being relegated to this only drawing user interfaces. And this does result in a higher workload for backend developers. But at the same time, when we're building this system of backend-driven UI, there's going to be a lot of work for all developers. Because one thing we have to keep in mind is this whole system is going to be based on the contract between the backend and the front end. And this contract will have to be decided by both the backenders and the front end. So at the end of the day, yes, it's going to result in a higher workload for developers, for backend developers. If it's a pro or a con for you, that's up for you to decide. But we're going to transition to the next point, is the high upfront cost. So when we're talking about the system that converts state into user interfaces, well, we still have to build that system. It doesn't come from scratch. And when we're building that system, this is going to actually transition us into our third point, is you're going to have to figure out a lot of stuff on your own, because this is going to be extremely individual to your specific product and your specific company. So there are a couple of talks by some of the bigger companies, for example, like Spotify, who said that they had to build a lot of things from scratch and they had to figure out a lot of stuff on their own. And this resulted, yeah, in them having to backtrack, maybe rebuild their whole approach, because at the first try, you might not get it right. If your contract starts getting out of hand, maybe it's time to pump the brakes and actually rethink what you're actually doing. And the last thing that I want to talk about is, I would say the most important part to consider is that it does destabilize the usual developer distribution. So me being a web developer myself, if someone would say, okay, I'm removing 50% of your scope, you're going to be now kind of relegated to creating, this is going to be a bad word, but a dumb client. Because all the client does, it reacts to state and pushes out templates. So depending on the developer, this could have very different reactions. Like one developer could be very happy that he has the chance to focus on what he does best, which is code user interfaces that are accessible, that are good looking, that are fast. But another developer, for example, me, I would say, okay, I do like doing the business logic stuff. I do like getting to know my product more, trying to improve it. So as I said, this can result in many ways, but this is something to keep in mind. Is this approach even for your team? Are the developers going to welcome it, or maybe they're going to backfire on it? And we looked at the good things, we looked at the bad things, and there are some very valid questions you might start to ask. So one of the main questions is if you're thinking about employing this backend-driven UI, how much should you commit initially? For example, if you have an old website, I would say it doesn't really make sense to start rebuilding it from scratch and make it backend-driven, because maybe the old website isn't very subject to change. On the other hand, if you're building something new, and you know that at the end of the day, you're going to want that flexibility, you're going to want that speed of development, you're going to want A/B testing, this is something you might have to implement. And when you're building something from scratch, it also allows you to basically not having to backtrack, as you're building the application together with this backend-driven UI. The second thing we need to talk about is we're not trying to invent HTML again. So when you're creating this contract between the front end and the back end, it's really easy to get lost in how many details you want to actually include in it. So if you start being too detailed, at one point you can start to realize, okay, we're using backend-driven UI to draw blocks and then color them like red. And at that point, we're inventing HTML again, but that's not what we're trying to do. Because the more detailed you try to do it, the slower the development process is going to be. And what we're trying to do is increase the developer velocity. So a very important part is to try and find a healthy balance between flexibility and actual development speed. And another, well, basically the last thing we're going to cover in regards to valid questions is, do you have the foundation to implement a backend-driven UI? So this mainly focuses on, do you have a design system? Because let's say we don't have a design system, we want to implement a backend-driven UI. We have a web application, and we have a mobile application. So if those applications look differently, it's going to take a toll on your whole implementation, because the contract is going to be all over the place, because it has to cover the mobile application, also has to cover the web application. So when you're implementing a backend-driven UI, all developers sort of need to speak the same language. Well, what does that mean? If we decide, okay, we want to add another button, that same button should mean the same thing in every context. Like a front-end developer should say, okay, this is a button, it looks the same as the one in the mobile application. And with this, we can start to do this unified client approach. Our customers are going to have the same feel no matter what client they're using. They're going to have the same features. And yeah. And I'm actually going quite fast for this, but okay. And for the closing thoughts, so these are the 4 main companies I based my research on backend-driven UI. So I started with listening to Spotify's talk about backend-driven UI, because I think they were one of the first ones to actually do it. And in terms of Spotify, what they needed was this extreme flexibility. They wanted to experiment with their user interfaces as much as they could. And backend-driven UI was basically a necessity for them. They didn't do it out of basically sheer boredom. This was a very valid use case for this. So when we're thinking about backend-driven UI, we have to understand that this is going to cost a lot. This is going to invest a lot of time. So do we, at the end of the day, need this flexibility and different way of doing things? Lyft had a very good podcast on their engineering channel about how they implemented backend-driven UI. And in terms of Lyft, they did it for mainly the unified client approach. They wanted all of their users, if they're, for example, one is using Apple, if one is using an iPhone, the other one is using an Android, they wanted both of their applications to have exactly the same feel. And this goes into the unified client approach. So no matter what client are you using, they wanted to provide the same experience, and this actually helped them a lot. And in terms of Lyft, yes, first of all, they tried to implement everything too detailed, and then they basically realized they were trying to invent HTML again, and had to backtrack and basically implement backend-driven UI version 2. And after that, they did succeed. Airbnb is a company that also went very heavily into backend-driven UI, basically for the same reasons as Lyft. And in regards to these companies, what we need to realize, these are some of the biggest tech companies in the world. So they do have the resources, but they also had a very valid use case for using backend-driven UI. Our neighbors at Vinted are also using backend-driven UI as far as I talk to them. So this is something that is employed by very big companies because you do have to have the resources to actually implement this. And not to end on a bad note, so I'm going to say something I heard from a couple of engineer managers from Netflix while they were discussing backend-driven UI. So if you commit to this approach, at the end of the day, you're going to increase velocity. You're going to be more flexible. And, well, those are the two main parts. You're going to reduce your time to market, which is, again, one of the most important parts for up-and-coming products, because we want to get ahead of the market and not get left behind. So, yeah, this is probably the note I'm going to end on. It's actually 3 minutes left. I know I probably missed something, so sorry for that. But yeah, thank you for your attention and questions.
Thank you, Domi. Really good one. We have already 2 questions. Maybe
no.
Evelina gonna help us with that. We have a question from Paulas.
Yes. Hello. Very nice presentation. So it seems like the biggest problem that it can very easily devolve that you just invented HTML, just instead of using HTML, you're using JSON to transfer the exact same thing. So what do you think are ways to prevent yourself against like reinventing HTML, and how would you, is there like some kind of guidelines in that area?
Yes, so I think this is the part that I missed. So basically, when you want to avoid inventing HTML again, design system is a very good place to start, because with design system, you have basically atoms that you're trying to represent. So the bare minimum you should describe in a contract is, for example, a button in the design system. So this is, I think, goes into, again, that you do need a design system if you want to implement backend-driven UI. And in terms of not going into too many details, you should try to be more general when describing this contract, because yeah, it's very easy to think that every single property in a button needs to be part of the contract, but this is something that we actually want to avoid. We want any person to be able to create a web page from scratch using our predetermined components that we can give it. If we need some new components, yeah, we're going to need to improve the contract. And yeah, so I don't know if it answers your question, but I would say you should start thinking from a design systems point of view, that this is the bare minimum we want to implement using backend-driven UI.
Okay, thank you.
Okay, we have another one from Iris. Yeah, can you pass the mic?
Okay, I actually have 2 questions.
Oh.
You mentioned that most of the benefits here come from the fact that you can iterate faster, you can come to the market faster. But how about the user's perspective? What do you think are the benefits or drawbacks of this approach from the user's point of view when they use the application that is driven by backend?
Yeah, this is also a very good question. So the one thing you have to think about, I didn't want to get into it in this presentation because we had a little time in general, but you do have to think about the performance because it's pretty hard to paint out some predefined content when you don't know what the content is. But thankfully, these days, there's a lot of ways to prefetch data. So from a user's perspective, nothing should change if the backend-driven UI is well implemented. If you're going to go to some route and you're going to wait a couple of seconds for the content to actually load from the backend and only then start to paint something, it's going to look terrible, right? So one of the best ways to prevent this is prefetching a lot of the state for other pages. For example, if you have some routes at the top of the page, you want to prefetch those contracts. So then when you click, you can instantly know what the content is going to be. But performance is definitely a concern. And I did listen to also a talk about performance in regards to backend-driven UI, but their main points was that you need to prefetch data and you need to be ready for this. And coincidentally, since front-end developers are kind of now exempt from the business logic, they can actually focus on this to create the best user experience, to actually prefetch content, and when the user clicks on something, that content should be ready for them.
Okay, that makes sense. And can I ask another question?
Yeah, sure.
Let's go.
Okay. Let me think about it.
I have one from Thread for
Oh,
you.
Jesus.
What kind of stack do we use in here? It's HTMX involved in here? This is the new tech.
HTMX?
Yeah.
Well, this is a very... It's not an old practice, but it was used like before HTMX was involved. So the stack is the same as your other applications. Like the only thing that changes is how you handle the whole user interface. If you go to a route, that route returns some state that you now paint out. So you can use React, you can use Go, you can use all the frameworks that you want. This doesn't tie into some specific framework. You're still free to choose.
Okay, thank you. I hope that answers the question. And one from me as well. You mentioned that we need to think about the people. I totally agree on that. How the companies kind of manage that? Do all the front-end developers went to the back-end and start to develop there? What did they do?
Yeah, I talked to one engineering manager in another company that employ backend-driven UI. So in their use case, one front-end developer basically needs two backend developers to basically compensate the work. So yeah, this is something that is definitely a touchy subject. And what was the first part of the question, actually?
Yeah, I'm just curious now, what front-end developers then do? Do they kind of go to backend and try to do the stuff in there, or they just, as you mentioned, leave, stay at the same team and try to go deeper into the UI and UX?
Yeah, so one of the options is definitely to go deeper into creating the best user interface that we can, because at least from my perspective, a lot of the time, maybe I want to improve this feature as much as possible. Maybe I want to make it AAA compliant with accessibility. And this is something that I just do not have the time to do because I have to focus on other things. So this does free up a lot of time for front-end developers, but as a front-end developer yourself, you can still focus on a lot of stuff. Animations get looked over a lot, for example. So you can go into a lot of these tiny details, but at the end of the day, yes, you're kind of getting relegated from this control over the business logic, and that can feel not that nice. But the Netflix engineering managers were actually talking about this. So one of the biggest things to consider is actually managing the egos of developers, because as a developer, you're used to some control, but now they're taking away and saying, okay, this person is going to take over your work. So this is definitely something that you have to talk to developers about. As I said, if this doesn't work for them, is it worth like breaking your whole structure because of backend-driven UI? So this is something that people have to be on board. But at the end of the day, if this is the best way to go forward for your company, like as a developer, you have to realize, okay, this is what we're doing. So it can be an ego check, but yeah.
Yeah. Ivar, do you want to continue with your question?
Yes, I remembered my question.
Yeah, sure.
So The buttons not only have to look nice or be placed well, but they also have to do something.
Yeah.
What are some strategies in describing on the server side what a button does on a client's device?
Yes, so this is a difficult topic. So one very, I won't say popular because I've heard it in one of the company's explanations, but they basically create this whole framework of actions. Like a button has some sort of action, they have this whole another system for declaring what the action does. So I can't really get into it, but you basically have to design another way of translating what the actions do. I can't really answer that question because I'm still a bit lost on that myself as much as I try to get into, but there are ways around it, and it's going to be, of course, difficult, but numerous companies have implemented it, and they did that using actions. So.
Good question, though. Thank you, guys, and thank you, Adomas, for a great presentation. We're going to come back in 5 minutes or so at 12, and we're going to talk about WireGuard. Yep, see ya. And we're back. We're going to talk a little bit about the most popular protocol in the world. It's called WireGuard. And Luca's is going to present about it. I'm really happy. If you don't know, NordVPN uses WireGuard, or well, NordLynx. And we use it for more than 90% of our people around the world. So, Lucas, take it away. Have fun.
Hello, everyone. Thanks for coming to my talk. And as Marius presented, I'm going to talk about WireGuard. And it's being used by NordVPN. So I'm going to dive a bit into what it is and how it works. The agenda is very basic. So it's WireGuard, noise, inaction, and what is meshnet. So the introduction about VPNs, very short one. So VPNs is basically a way to establish secure connections between networks. Those networks, of course, can be just one device. And you can use VPNs to bypass the geo restrictions and extend your local networks to work in some secured network as if you would be just part of that network. And famous VPN protocols include NordLynx, this is one of ours, then WireGuard, and NordLynx is based on WireGuard. OpenVPN or iKey, and there are, of course, a few more, but these are what Google shows as the most popular ones. So what is this WireGuard thing? So WireGuard is VPN sort of idea and protocol and implementation in one, which offers these things. It's very modern and secure, it's very lean, and it's very efficient. And why WireGuard is modern and secure? So WireGuard implements the noise protocol framework, and I'm going to talk about it a bit later. But basically what that means is that WireGuard's crypto and hashing algorithms are chosen to be very modern, very fast. They should work pretty fast, even on unspecialized hardware, which means processors without dedicated instruction set, like for example for AES ciphering. WireGuard also has no crypto agility. It means no handshakes to deal with what the peer supports, what you support, handshakes, bit sizes, nothing like that. Basically, it's like in case something breaks, everyone needs to upgrade it because there is no versioning and similar things. So it lacks this crypto agility, but as a nice benefit, it also means no downgrade attacks, where you convince your peer that actually you don't support this newer, more secure version, so please use this older, a bit worse version. Also, there are less chances to misconfigure. And as a side effect of this simplicity, it means that WireGuard is pretty small in itself, so it's much easier to find issues with it, and it's much smaller surface area to explore. There are also formal proofs with dedicated tooling to describe WireGuard's handshake process, the whole thing, and to prove that actually it is, yes, secure under some certain circumstances, like for example, not using quantum computers. What does it mean to be lean? So WireGuard's implementation is around 4,000 lines of C code in Linux kernel, and the lines of code is not like a perfect metric because, well, you can cram all of those 4,000 lines into actually one line. But it's like a good comparison, sort of like overview. You can see on the bottom chart, it's like planetary chart. You can see on the right side the small dot, which is WireGuard, and you can observe how small it is in comparison to, for example, OpenVPN or IPsec. And WireGuard only cares about secure communications, nothing more. Basically, it's the problem WireGuard tries to solve basically is to establish a secure channel between two ends, nothing more. The white paper of WireGuard is 20 pages, which should show like the simplicity of it, and that also includes like references, a blank page, the introduction page, and like everything else. So for efficiency, I already mentioned the fast cryptography algorithms, but also there are a few more things to why it's so efficient. So first of all, it's Linux kernel implementation. I'm going to expand on it very soon. And non-chatty protocol. So basically, WireGuard doesn't have any sort of like control. Basically, if you send data, it does a thing. If you don't send data, WireGuard basically stays silent, which means a lot of good things. So one of those things is that you don't generate any traffic, which means it doesn't saturate network unnecessarily. Basically, if you have two devices connected with WireGuard, well, this connected thing only matters when you are actually exchanging data. If you don't exchange the data, basically it means there's no active session. The moment you send some data, WireGuard kicks in and does everything for you, encrypts the traffic, and it just works transparently to the user. So the protocol is very not chatty, so it preserves resources. And this is especially crucial for mobile devices, because for mobile devices, to send data, it requires using the radio. And radios in mobile devices don't like immediately go up from the sleeping state. So they take some time to go from the sleeping state to the high state and then stay there for some time. So like it depends on the operating system and implementation. Official Android's like documentation tells that it stays there for 15 seconds. So in case you would just send some control messages needlessly, basically you just drain battery for 15 seconds really unnecessarily. And also, as a side effect, it provides some stealth. So basically, you can't really observe WireGuard happening if, well, there is nothing happening. UDP-based protocol, which means it has very minimal overhead. It doesn't have any intricacies of TCP protocol. It's very plain and very simple. So expanding on Linux kernel implementation. So WireGuard's like de facto standard implementation is now, as of Linux 5.6 kernel, inside of Linux kernel. And that means a lot of good things. Well, like first of all, like no data copying between kernel and user space. So for example, the kernel would have the packet, would give this packet to the user space, it would encrypt it and whatever. So basically all of this is bypassed. No context switching to do this stuff. No like pinging from kernel to user space and vice versa. No spending resources there. And so this also means lower latency and higher speed. Well, basically because you do less stuff. And as a side effect, I think it's also more secure, but mainly because it's inside of Linux kernel. So that probably means it went through Linus Torvalds code review. So that should be good already. And also because it's in Linux kernel, it means if you're using later Linux kernel versions, which you should, basically it means you already have it. So there are more intentions to actually make it good because you already have it and everyone has it. So your fix or your optimization actually matters for everyone, not on your like custom implementation of WireGuard protocol. So I would say it's more secure based on the increased intentions to fix it and optimize it, and more eyes looking into the protocol. The protocol itself of WireGuard is very minimal, kept very simple. So basically there's initiation message and response message to this initiation. So basically I tell to another device that, hey, I want to do a handshake and here's some data. He sends me some data and the connection is sort of established like the session. In case the peer is very busy and wants me to somehow prove that actually I'm a legitimate peer, not like just replaying some old packets, it might reply with a cookie reply message. That's sort of complicated what it does behind the scenes with crypto, but basically it sort of makes sure that actually you are a peer and not like spoofing IPs and just basically DDoSing the device. And then there's a transport message, so basically it's just a packet that's encrypted, and that is it. These are 4 messages described in WireGuard spec. So the thing behind how WireGuard routes the things and whatever is called crypto key routing. So it's actually a very simple mechanism because crypto key routing basically just means that WireGuard interface just has a private key. You keep it private. So basically the interface has private key. You don't say it to anyone because you will compromise yourself. And UDP port and a list of peers. You simply manually configure. And the peer is identified simply by the public key. And that is it. The peer consists of public key and optionally an endpoint, but endpoint is learned once the peer actually connects. So you just need to show the first IP just for the communication to happen. So in VPN case, VPN server doesn't have any endpoints. Basically just clients have VPN servers endpoints. So the first communication could happen and then the server learns the endpoints and it just magically works. So the peer's configuration only cares about the endpoint and the public key, and that's it. So this crypto key routing based on the keys is very neat because it basically doesn't care about any extra stuff, like for example, IP addresses. Basically, if the packet comes from WireGuard's interface and is from allowed tunnel IP address, basically that's sure thing that this is the peer we are talking about, and all of the regular routing firewall rules just work out transparently. So this is a scheme I drew to illustrate both points. So let's see what happens when you send data. So you send data, somehow, magically, it happens to arrive at WireGuard's interface. Then WireGuard simply inspects the destination address, selects appropriate public key for this peer, and simply encrypts and sends the data, while in between doing the handshake thing to establish the connection, secure communication. When receiving basically is vice versa. The packet arrives at WireGuard's interface, then it's authenticated, decrypted basically, and if the decrypted packet's IP isn't in the allowed list, basically it's just dropped, and that's it. So this process is pretty transparent from the application's point of view. For this to happen, we need to use something called tunnel devices. Tunnel devices, this is cross-platform term basically, used in all the major operating systems. And the tunnel device is just software-defined network interface. So, for example, on laptop, on mobile phone, I have cellular network and Wi-Fi card, and on laptop I might even have Ethernet card. So basically, these are physically based interfaces. But in order to somehow do something with the packets, we need some software-defined interfaces, and those work on the OSA layer 3. And those offer a very nice abstraction towards the applications, because basically they appear just as normal interfaces you can configure, route traffic to, and whatever. So through the power of abstraction, the applications don't even know that this is a fake interface. And I try to draw a funny schematic of this abstraction, and that the user simply prints a page, and he doesn't really care that the printer might not be a real printer. And the person is very happy because PDF printers actually work properly. This is the tunnel flow for sending. This is exactly the same for receiving, just vice versa. So reading from left to right, basically we have this IP packet which goes to operating system, and then the routing table of operating system is simply consulted. So in this case, we are communicating with our WireGuard peer. And in this case, the routing table should be set up properly to route this to the tunnel device, where WireGuard actually listens and does stuff. So routing table shows that it's destined towards tunnel device, and then goes to this tunnel device, and WireGuard simply encrypts this packet like a Matryoshka doll, it takes one IP packet and simply puts it into another packet as a payload. And now it's encrypted, and it's injected to the network stack again. And so it hits the system, the routing table is consulted, and now it actually shows to the physical IP address to actually reach this machine. And so it goes out. And when it comes back, basically, it's the same process, but just in reverse. So basically, you first receive a physical packet with physical IP address. You decrypt and decapsulate it. And now you see WireGuard's internal packet. And so basically, the whole process goes from right to left, basically, and the application is hit. One nice feature about WireGuard, as I mentioned about crypto key routing and only public keys, is that it basically out of the box supports roaming. And this means that simply WireGuard doesn't care about the IPs. It only cares about keys. It simply learns the IP the moment you authenticate properly via a handshake. And so that means that, for example, if you're on a mobile phone and you switch between like cellular and Wi-Fi, basically you don't need to do absolutely nothing. Of course, it doesn't come with like, it doesn't like work magically, because still the peer will try to establish communication with your last known IP, and if it's not there, well, he will fail to do so, so you need to send some data to him first. This needs to be managed by some outer software. WireGuard doesn't really do that itself. It has this feature of persistent keep alive, which simply sends data at repeated intervals. But in case you have disabled it, basically you have to somehow trigger the sending of data from some other means. So my joystick doesn't work. Okay, the DOS and cookies. So I just briefly mentioned the cookie system. So WireGuard uses cookies. So basically this means that if the server is under load, it basically responds back with a request to actually use the cookie provided by WireGuard and send it back. So basically this shows the ownership of IP, and that the sender actually didn't try to like spoof a ton of IPs and basically make WireGuard do a lot of like key initiations. And this is pretty expensive operation, because actually doing the whole handshake, the whole asymmetric crypto, it's pretty expensive operation. So WireGuard tries to sort of minimize that, but of course this means that if you're like a legitimate peer and you try to do bad things, well, this sort of doesn't really help. Okay, this has some delay. Right on the timer slide. So WireGuard is based on some timers. Those are pretty basic ones. Basically, every session happens every 2 minutes, 120 seconds. Each retry for the handshake happens every 5 seconds until a 3-minute mark. And after that, basically, WireGuard ceases to do anything. So this enables some nice things, like frequently rotated sessions means also forward secrecy. This means that if, in case you would record WireGuard's traffic, basically you wouldn't be able to decrypt what was in the past. Yeah, and WireGuard also has this nice thing called passive keep alive, which basically means that if you don't send any data back, after 10 seconds, basically, WireGuard itself it will generate an empty packet and will simply send. So basically, if one of the nodes is constantly streaming data towards other peer, and because it's UDP, basically doesn't require like any sort of like acknowledgement, WireGuard will simply keep pinging those empty packets every 10 seconds to let you know that you're still alive. Implementation. So WireGuard is actually implemented on all operating systems. You can even have it on your like Android TV, Apple TV, basically whatever. I think ESP32 is also on there. So the kernel implementations are, the famous one is Linux, because it's like the reference implementation done by the author himself. Then there's this WireGuard implementation and Android kernel implementation. So Android is with an asterisk because actually the support is there, but it's not like exposed to the user space yet. But that's on the right track. We can assume that we are gonna have it. And there are multiple user space implementations, such as WireGuard Go or Barrington by Cloudflare. So what this should show to you that actually you have a lot of to choose from. Basically, all of the main platforms are covered. And you should always prefer the kernel implementation, mainly because it's more efficient and it's faster and preserves resources. So a brief intro on the noise. So the noise is a protocol framework, and it's pretty hard to grasp the idea. Well, like, what does that mean? Is it like a library? But actually, it isn't like a library. It's like more of an like idea, like a 40-page PDF, basically. So what noise does, it tries to like split the secure communications down to bare building blocks, and then allows you to reassemble them with some guarantees to achieve whatever you want. So it also defines the hashing and crypto primitives that are like modern, secure, and fast, and allows for this flexible combination of those components. So WireGuard uses noise IK pattern, like these are like officially defined patterns. And this pattern simply differs from others because it allows for one round-trip establishment of the handshake. So basically, you send some data, and I receive some data, and that's it. The security session is sort of established. You could actually say that WireGuard is actually just an implementation of noise IK pattern. Basically, the whole like security thing is actually in this pattern. Everything else about WireGuard is basically just, you know, like meta stuff like routing and other things. So let's see how it looks like in action. So for Linux, we can simply use VGQuick utility, which is just actually like a bash script you can just download with apt, and that's it. And for other operating systems, you can actually download NordVPN. Yeah, so VGQuick. So what I like about VGQuick is actually that it sort of like, it seems intimidating because it's nothing like UI-based, it's like command line, but just see how small the configurations are. And I mentioned that the left side is server, and for some reason I don't see the client on the right side, but actually these are like not real names. Like there is no server and the client in WireGuard. Basically there's initiator and responder. And I guess in VPN case, you could say that the client is actually the client because it initiates the communication. So you can see on the server, it has this interface tag, it has the address, listen port, and the private key, and then it has the peer identified by public key and the allowed IP. On the right side is the client, which basically is simply the private key, the address, and basically the same thing, except it also has the endpoint. So it is assumed that it's going to do the first communication, and the left side is going to learn this real endpoint. And that's it. Once you have these two configurations on your two different devices, you just do VGQuick up the config, and that's it. Actually, just one command with this small configuration file. What's nice about WireGuard and the simplicity, basically, if you set up the keys correctly, it's just going to work, and the allowed IPs. If you set up something incorrectly, it's not going to be like working, but you know, unsecurely, it will just not work. Introducing MeshNet. So it's a feature under NordVPN. And so even though I described like MeshNet, WireGuard, like about this secure, efficient, lean, like modern VPN solution, real life is a bit different because in real life we have like NAT devices, like we have firewalls, we have routing, and sometimes we just simply can't like establish actually a connection between two devices directly. And for various operating systems, we also need different software. So despite how WireGuard is cool and good, we still have some like these issues to think about. So let me go to another slide. So we have MeshNet, and it's a feature under NordVPN, which is based on WireGuard. So yeah, so MeshNet actually handles all of these necessities for you. So it allows you to access your LAN securely from the outside, or to use your other device as a VPN server, configures the routes, the firewall, basically everything for you. And as a nice feature, in case everything else fails, it simply has a relay option, which so happens to work transparently because of deploy servers by NordVPN. And basically, in case everything fails, the data is relayed securely through these servers. And those servers themselves basically don't have any idea what this data being transferred through them is. It's just like random mess from one end to another end. And due to the security, like the crypto key, like the vault cryptography, the noise protocol, whatever, basically, you can't really peek into what's inside of it. Of course, until you like compromise the keys. And I wanted to include some screenshots of MeshNet, like how simple it is. So you can see, like in this case, you have some devices in your like virtual like private network. And it is as simple as that. And you can simply configure each route. This thing needs to be fixed. And you can see the options you have, for example, for one of the peers. Like in this case, it is highlighted that actually I want to access local area network from this device, or I can route traffic through this device. So basically, it's very uniform, like GUI experience for all operating systems, including mobile, to use WireGuard for secure communications. Here you can get it. And also, I included some resources I found very useful in this journey, and I would simply highlight that official WireGuard website is amazing at presenting itself. It contains everything, the white paper, the tricks, tips and tricks, whatever. So basically, you can just visit wireguard.com and learn everything in depth. And thank you.
So you already know everything about the WireGuard right now. Maybe we have some questions from the audience. Yes, we do. Jakub has one.
Okay, so do you think there is some space to improve WireGuard? Like, for example, when we are using it, I don't know, either extending the encryption, because, for example, AES NI is way faster than Chacha from what I've seen. Or is it like what we have right now, and maybe what we should focus on is seeing if we can utilize the Android kernel implementation? What do you think?
Thanks for the question. So I don't really have opinion on myself about that. I trust that it was like I read multiple like papers like proving that actually the current like security like works properly. The Chacha 20, for example, is very fast, even on like regular CPU. Of course, it's not gonna beat like AES and dedicated like instruction set. But what I found interesting regarding your idea is that I listened to podcast with the author, and basically he was asked like, you know, did you why there's no like RFC for WireGuard? And basically he mentioned that, well, he thinks that the simplicity is the key, and this is good enough, and it must be like lean, efficient, fast, and secure, basically. And until proven like otherwise, basically there should be no changes.
Thank you.
Okay. Any other questions? Oh yeah, we have some.
Hi.
Hello.
Today I saw a slide where NordLynx performs slower on some medium-range Android devices than some other VPN protocols. How to improve that?
I guess the best bet is to wait for this kernel implementation to be available to use. That's gonna be like the best optimization. Other than that, well, as WireGuard implementation, like the NordLynx, it should be like fast already, so maybe it's doing something which it shouldn't do. Can't really say much else.
Yeah, we need to dig the deep dive into Android, I guess. Ivory, yeah.
In the beginning of the presentation, you mentioned that simplicity of the protocol is one of its main features. And as a result, if anything goes wrong with the protocol, the only option is for everyone to update. Have there been cases where something did go wrong and everybody were forced to update?
So no, I haven't encountered this yet. However, the WireGuard thing itself is pretty new. I think it's only like several years old now. And it's maintained by this one, I would say, hyperactive dude. But it's like in the open. I mean, you can contribute to it as much as you want and do implementations. But so far, it seems that then actually what gives it some credibility is that this noise protocol was sort of not like set in stone, but actually WireGuard, like implementer, actually sort of like improved the noise protocol as well while implementing it. So it was like not only one person's idea to do it right, but actually it was like multi-people effort to get this right through like iterative process. And to give some credibility on the noise protocol, it's being used by some huge companies as well, like for example Signal or WhatsApp. So it's not like some like in-house built solution only one thing uses.
Okay, thank you guys for the questions. If you're gonna have more, shoot them in thread, and Lucas is gonna answer those. Thank you, Lucas, for the
Sure
presentation.
thing.
And next we have Marta on stage. She's gonna talk about data, I guess, right? Yeah. Take it away.
Hey everyone. Accidentally, my presentation title was the most obnoxious and hidden one, so I'm sorry about that. That was not intentional. I thought we're going with the tradition once I realized it was too late to change it. So it's called Own It or Double It and Give It to the Next Team, but in reality, it's about different things that we can do to make our data better. And the agenda is essentially, I want to talk about AI ops. I hope you haven't heard it. If you have heard it, still might be interesting. Then a bit cover what is needed to do anything related with AI and data science overall. That is not possible without talking about data quality, which can feel like a quicksand sometimes. And then, real and simple, I'll try to convince you to own your data rather than not own it, double the problems, and give it to the next team. So quickly about how I stumbled upon AI ops, because I lead the data analytics team. That is not a common thing to stumble upon. So last year I turned 30, and as everyone who has their age ending with a 0, you know that it's a painful process. So some people my age buy real estate, some people run half marathons. I decided it's a wonderful idea to go full-time studies. In practice, that was not so great. First off, you don't really fit in when you're 30. With 21-year-olds, you're like, oh my God, I'm not relevant anymore. And I'm not a student anymore, but I'll show you a moment of my downfall of December 21st Eve when I stopped recording a presentation for an advanced machine learning course. This was my actual face. So just consider about your 30th or 40th crisis, like just don't do it. Please remember this face, it might become relevant later. Anyway, what is AI ops? It's essentially machine learning for IT operations. So if we look at it like that, it's like a big buff guy that could help you handle your IT operations just a bit better, a bit more automatic, a bit more reliable, if it works, obviously. So it's using big data and big models mainly for two main things that it's being used for right now. It's either resource management or incident management. Since my daily work comes together a lot with quality of service team, essentially I am that team, we really care about the user experience. So today I'll talk a bit more about the incident management part rather than resource management, because of course we have unlimited resources, right? So there's many different ways how we can manage incidents. They're divided into two main groups, being reactive and proactive. I think the names are self-explanatory. So reactive is shit happens, we react. The other one is we react before the shit happens. So palliative one is where something happens, we fix it, and we hope it never happens again, but it's probably going to happen again. Curative is the one where we fix and we also analyze the reason for it. And then hopefully the issue doesn't come again and it has a bigger likelihood that it won't happen again. The planned maintenance protocol would be where we break our own systems on purpose. Then we see the boundaries that it can extend, we fix it, and we make it more resistant to any threats or problems in the future. Condition-based, as the name suggests, we select a threshold that we see in that might cause an issue. Once that threshold is reached, we send an alert, we fix the problem, and move on. The latter two, I believe, are the ones that we use the least in practice. Those are predictive and prescriptive. Predictive meaning we use either machine learning or some other logic to predict the issue. We fix it, and it's fixed. And prescriptive one, in schematic, looks the simplest, probably to implement is the hardest, is where the system does all of it on its own. And these two are the best ones, because if you pay attention to the arrow colors, and I'm sorry for not choosing colorblind friendly colors, but the green ones are where everything is up, everything's working. Whereas the red or yellow ones, it's like, okay, something's not working. So from a service perspective, we're the most interested that everything would be up 100% of the time. So that's our goal, right? So how exactly does it work in AI ops context? So AI ops is pretty much everything in purple color. So we gather some metrics, we store them somewhere, and then we do a bunch of stuff to gather insights. And if you look at some specific circles in that purple color, it won't look like rocket science to you. So the teams do reporting now. You might be doing some preemptive actions or doing some predictive alerts right now, analysis, you name it. All of these things we are doing right now. The point of AI Ops would be that we take all of this together in a cohesive way and we deal with them all at the same time, rather than including manual human effort to, okay, we report, something looks fishy, okay, let's try to diagnose, maybe mitigate, okay, we'll need to set up alerts. So all of these take a lot of time, and AI Ops is meant for optimizing that. Just to dig a bit deeper, what it does, it takes first off the perception. It's not limited to one layer of data, but it takes everything all at the same time, which is kind of risky. But it could take technical data, so meaning, for example, servers RAM, application data, so all the events that you can imagine, functional data, so network traffic, API endpoint results, and business layers, so all the metrics, all the KPIs that we consider in product meetings and similar. And it would take also real and historical data, so that's where we are. It's looking at potential failures, meaning failures. And it's trying to predict before it actually happens, so reducing the downtime. Detection, meaning pointing out the anomalies and the symptoms that could cause the error, and at the same time locating it. So performing a root cause analysis and uncovering hidden dependencies. So for example, in a good case scenario, I could say, increase of RAM by 20% will make the user experience worse by 50%, right? That's the type of metric our team would like to have, but we don't. And action and interaction, so with many different incidents to prioritize them, assign the corrective actions automatically, and just raise the issues for a human validator in specific cases where it's really needed. Sounds wonderful. Let's do this. Of course, once you hear AI, it's not so easy and straightforward. So I took the liberty of creating an AI Ops implementation checklist and assigned my own understanding of how far we are from implementing it. So the first thing, we need people and resources. And I imagine if we want to build something, we can do it, so we have it. Second part, data management platform. Well, that one could be trickier, because as I mentioned, it would be logs, traces, events, incident reports, all these different things would need to be considered. And building a data management platform for that type of scale is difficult, to say the least. So if we would want to do it, that would be a work in progress and we would need to work on it. The need for such a model, any person standing before you here today is biased about their topic and they love their topic. So I will say, of course, we need a model like that. However, I do believe that our client base is expanding, our servers are expanding, the number of dedicated IPs we issue are expanding all the time. So there is a bigger chance for incidents. So perhaps we would benefit from a model and reduce the amount of time people are going through perhaps repetitive actions or the time we take to resolve some issues. So let's say that we need it. Another difficult part would be the trust in a model versus a human check. If your team has any alerts set up on data, I imagine the typical workflow right now is you have a Slack channel, it receives an alert, and then someone's like, oh, okay, I gotta go check it. Then you go into a dashboard, and maybe first you check, did the alert actually work correctly? Okay, why did it happen? And all of those are performed mostly by people. If it's not by people, please let me know. I'm very curious how your team does it. So it would take a lot to trust a model to say, yeah, this is the issue. So let's say changing that mindset would be a thing. But the biggest problem or opportunity is quality data. And I imagine that's any action that we want to do with data science or AI is about data quality issues and consistency about it. So I'll show you something about data science and what is needed for that. Pretty much a pyramid scheme, obviously. And you need to have a strong foundation with your data stuff. So it has to be a reliable data flow. You have to validate your data, and it has to be normal. Otherwise, you will build a data science model on like AI or machine learning model on top of it. And you will see some anomalies where the anomaly is actually caused by a script that's broken and just not sending data. So here's the same scheme, just in a simplified way. And there's two areas, I think, that are apparent in the collaboration of, say, analysts or data people or people that work practically and people that work business or delivering the results about users. This is the part that I call area of direct business value, right? This is metrics, dashboards, and other cool stuff like good machine learning models are the ones that impact the user life directly. If we have an increase in metrics or we measure the right things, then increased speed, for example, we know that it has a direct business value. So it's very easy to, gather that value. Whereas the other part is not so interesting. It's like 30 days out of 31, everything might be working fine. And then there's one day where data is interrupted and the dashboard looks all wonky. And you're like, oh, did something happen or is it just data? So I call this area of tech debt, where I think we are likely to skimp over the data validation parts in order to deliver something quicker and get to the results that we're the most interested in. So again, with the pyramid, it's not all bad news. You don't have to have a perfect data all over the place to get something working to the point of a model. I like to bring up the example of CAPTCHA data, where we have a script on a server that's running, gathering data, and only our team is owning this data. We use it, so if something happens, we are aware of it, we can react to it quickly, and it's a pretty, if we would want to build models on top of it, we probably could with some minor modifications. So not to say that it's perfect, it's definitely not, but it's so concise and then within one box that it's very manageable. Then there is an example that is a real number. I won't mention the specific metric, but I was looking into it and I knew that the metric is available in two places. It's available in Tableau and it's available in Grafana. So I go to Tableau. The number that I need is 3.6 million. Okay, cool. That matches my expectations. This is exactly what I need. Looks pretty great. The number in Grafana, on the other hand, 3.4 million for the same day, for my same understanding of what that number is. So this is me sitting by the computer and just trying to figure it out. So it's 5% or so, and that number is very important. So what happened? Then I put on my investigative cap and go digging, right? So I have the numbers. So I talk with the dashboard owner in Tableau. I dig deeper. There's a table in BigQuery that it's coming from. It comes from a different table in BigQuery. And then I talk with 3 more people that are like kind of, maybe I know, maybe I don't. And I kind of get to the source, but maybe not really. That's why the star. It's a work in progress. And the same source is being used to get it into Influx and get it into Grafana. So the problem between these two numbers then appears in the level of aggregations and what kind of steps we do with the same data. It's the same data. So data lineage, honestly, is the answer. And it sounds like an abstract concept of data analysts that we're created just to create ourselves a bit more work. But it's not that bad. It's pretty simple, and you should all do it. So the principles are very simple. You look at the data point at the point of its, at the source of it. So either you buy the data from a vendor or you make it on your own, for example, from a monitoring script, and you follow it through up until the point that it's in the last dashboard. And you have this accountability matrix, so to speak. You also not only document the source and the ending, but also its meaning. So do we have the same understanding about the same number or not? Because that can be lost in translation as well. In my previous company I worked with, we had people that worked on explaining that year built and construction year of a building is the same. It means the same. Yes, it's the same. Okay, cool. So you also have to describe transformations and aggregations that happen along the way. So that is about the logic. What does it mean, average server load per day? Do I look at all the servers and say, what is the average load of them per hour, and I aggregate that and I take per day? Or do I take every single data point for all the servers for a day and I say, this is it? So whatever the decision, no right or wrong here, but just documenting that and communicating that with the stakeholders, right? Also taking note of the business logic, because that is also important. So for example, we have restricted countries. So very commonly we filter out countries like China. For some, it seems obvious. For someone who's onboarding and who's new, they don't know, and then mistakes are prone to happen. And of course, making it available for all stakeholders that are working with your data, so there's no urban legends. It's like, of course, everyone knows it. Like, never say those phrases. No, not everyone knows it, so just making it transparent. And the most difficult part, probably, is keeping it alive. So you do this exercise once, and then your data structure changes. So you need to maintain it and keep it live so that it's not outdated data, which can be maybe even more dangerous than not having that. So if AI ops topic didn't stick and maybe data science topic didn't stick, I want to leave you with a mental checklist for every single one of you. Even if you don't work with data, you must have some OKRs, and to back up your OKRs, you have some numbers. So ask yourself the following questions. Can you trace the journey of your KPIs? Do you know where it comes from? What's the aggregation? What's the journey there? Do you know that or not? Because it's very important. What are the procedures if something looks bad? So do you know where to report, who to talk to, who are the key people when something is bad? Because in a moment of panic, that's very, very important that you have the key people or key channels or whatever, where you can report these things and be sure that it's taken care of. How much data would have to go bad for you to notice it? Is it like half of the data is gone and you're still living happily with your metric that it looks solid and good? Or is it just one record that will make your metric go crazy? So it's also about the data sensitivity here. And lastly, about how often these conditions change. So something to consider for the maintenance part of it. And if I may, some more unsolicited advice. I said data lineage. It doesn't have to be fancy. So honestly, for all intents and purposes, it can be a Confluence page. Just don't make it a paper notebook because that's super not safe. But the fancier the tool, the easier it is to manage, maintain. But as long as you keep it somewhere and are able to share that knowledge within the company, you're good for now. Speak up. So better to over-report any issue that you see rather than not report. I've had situations where I report a data issue and then I scroll 2 messages up and someone's already reported it. I feel stupid, but at least I did it. And lastly, prioritize. So if you have any metrics that are concerning user impact, all this mental checklist applies to you even more than other people. So that's essentially it. I want to leave you with this thought that all of this was AI. And if anything, AI ops might be a hype. I do recognize that. The term was coined in 2018. But at least if you clean your data and do all the good practices, you might be able to do something else. So once you're done with that, let's see if AI ops is still around. Thank you.
Hey,
Hey.
a great one. Do we have any questions? Donate, I'm looking at you now. Fully
Cool.
supporting everything. Anyone else from the audience? Yes, one question. The one and only Amu.
Hi.
Hi.
I don't know how to formulate the question, but well, your drawings are very linear. When you get the data, you put data to some database, then apply some sort of analytics or other computation. But we have so much data and continuous flow of data. For example, When we get metrics from servers, we do this probably every minute.
Yep.
So we lose a lot of data by that. We just have a snapshot every minute. Or the same applies to client devices from the application. And it is very, very expensive to collect all the raw data into one database and then make computations. Do we have any plans, I don't know, to change that flow so we bring AI or any other analytics closer to the source of actual data, to the servers or to the client side?
I mean, everything that I talked about is a purely theoretical concept because we don't have the foundations in most places. I would say that would be a wise thing to do. At the same time, it's more about communicating what we've done with that data, or for example, to test it on a POC data set. It doesn't have to be the whole 5,000 something servers and every minute data points. That is usually the painful part that we deal with in terms of understanding anomalies. Once we aggregate, we lose some of that visibility, but it's always a trade-off, right? How much do we want to pay for data storage and processing versus how much benefit we gather from it? So we need to get the basics in order before anything.
Yeah. Anyone else? I have, okay, Ivaris, yeah.
One thing you focused a lot on is traceability or the linear nature of the data, so that once you see anomaly, you can trace back to its source.
Yeah.
Doesn't AI sort of go against that? Because one of the properties of AI is that it's sort of a black box. It's a one-way function. When you put data in, you get an answer, but it's very difficult to see why the answer is what it is. Doesn't that sort of would raise a lot of issues when something goes wrong?
Sure, and I think I mentioned that as well, because that it would uncover those hidden dependencies, right? Where something goes wrong and we don't really think about it in a human way, that these 3 suspects and features are causing it, but it could be 200 of these features that we just put in and it points out the result. It's more about making sure that every single one of those features that goes into AI ops is correct and accurate on its own. Because if we see some issue and we point out to that metric, and later we figure out that there's a data quality issue, then whatever we've done with the AI ops is just becoming useless in an essence. So, yeah.
Okay, and the last one from me. When are you going to go back to university again?
No, please no.
Thank you, Marta, for a great
Thank you.
presentation. Yeah. So we're going to go into break now, lunch break. We have an hour and so, and we're going to come back 10 to next hour. See you around. We are back. I just wanted to remind you guys that we have a quiz and you can win these awesome, beautiful t-shirts that we have special for this event only. The quiz is out of this area. You can find the link in there. It's only 5 questions. Some of them are really easy, some of them are hard, but yeah, try it out. And another thing about the Sparta, I'm gonna maybe talk later. Yeah, Himanshu, welcome to the stage. And he's gonna do the... Yeah, he is the expert in Android and gonna talk a little bit about it more today, right? Take it away, enjoy.
Thank you. I'm audible, right? Perfect. So, hi, I'm Himanshu. I work in the Android team of NordVPN. My responsibility pretty much lies around how we can break things in Android. So that's what we do, like the 8-9 hours we do in the every day. So this is my second time I'm specifically doing this talk, but every time I do this talk, I always have a slide where we say, this talk is sponsored by NordVPN, just to get the laughter out in the session. But this event literally is sponsored by NordVPN. So did not want to do that. Just jumping around to the agenda we have. So we as a team did certain changes in the NordVPN application. Some good, some bad, maybe we don't know. The users give us the reviews, but this specific topic is about certain things which we did good and went out to the users. We are going to talk about that, how we decided to migrate our view system to compose a new UI toolkit, and we implemented few of the other libraries called baseline profile and other stuff, and how we made that entire process easy for the developers who build on the NordVPN Android app. The surprise topic was actually there, but I'm actually surprised with the 20-minute timeline, so that's out of the picture. So starting off with the implementation, how we have for the Jetpack Compose. And just to give a context, Compose is a toolkit we use on the Android application, right? And so this is one of the ways how we set the UI for the users, whichever you see in the screens. This is another way of just setting the UIs. And this is pretty much similar to the React.js, how we build it. But this is not just the part of it. It is just a basic implementation of saying hello world. And just that makes me a developer as well. So going around that part, we have implemented the entire app, or maybe we would say migrate the entire app in Compose, right? So this thing is about how we made our application a bit more usable, a bit more fast of what we had, right? So this is one of the videos we had before implementing the performance improvements. So this is how it looks when we started the app. You see the difference. And then we have this after the implementation. So this was the snap we created. And this is just a starting point where we have the app startup time. But when we started calling around a different use cases, this was just one smaller part of it. So we created a magic around this snappy loading. We used baseline profiles. The team was more responsible for doing this, but to understand baseline profiles, what we have to understand how this actually works, right? It is like a basic process which builds up the entire flow of a certain application, let's say the login flow connecting to the VPN flow, or even the startup time, right? So that let's understand that. And to understand, I have this analogy, and this is a very weird one. So baseline profile works on the ahead of time compilation. So when we talk about ahead of time, what we discuss is when we have to cook something, if somebody chops the entire cuisine for us and just gives us to cook, that takes less time compared to just in time, where we have to chop everything ourselves and then we have to cook. So it's but obvious that the majority of the time will be going on the just-in-time compilation. So what baseline profile does is just it takes everything pre-compiled, ships to the user, and just makes the entire flow fast, whichever we have migrated it for, right? That was the basic concept of the theory. Now let's go to the implementation part. And please don't fire me if I bore you with the Android stuff here. So we just create a basic module here by the Android Studio. This is one of the tags we have to add, where we add the profilable. This makes sure that the baseline profile can work on our application. This is all the snippets which we have been using. Then in the Gradle file, we add a benchmark block of code. But in this entire thing, the most important part is the ProGuard files. Now, the ProGuard files is a basic set of rules which is implemented in the code, right? So this is the major implementation. And this file just contains one line. Do not obfuscate. This basically means whatever we generate, for what I say is ahead of time compilation, whatever the files we generate, it does not obfuscate and ship to the user. These are the specific files, should not be, right? So this is the one line we add there, and just we go around with the entire flow. So how do we work with baseline profiles? We need to first understand what critical user flows we have in our application. So when we discuss about NordVPN, the most critical flow is maybe the startup time, the login time, VPN connectivity, or maybe the home screen, right? That's the user flow. And this user flow can come up with the discussion with the managers, product managers, and everyone. So for that, we had a creation of an abstract class scaffold file. This is more of a generic file, which is implemented in all the user flows, right? In this, the main important part is this abstract function, which has an invoke, and that is being called inside the profile generator function, which we have. Now in this, another rule we call is collect baseline profile, and the max iteration means 15. So it will run itself 15 times to generate a specific file for a specific user flow we are being using, right? So this is the iteration. This was the setup we completed with the baseline profiles. And now the video we saw of the startup and we wanted to pull off the startup screen, this was the code implementation of it. So now the scaffold generator, which we created, that scaffold we created and added to the startup baseline generator. And here we have implemented that specific file. Now, if you remember the invoke function that has been overridden here, and inside that, we just call the start activity and wait. That specific line of code opens up your flow or the application and just shows this to the user, right? Now, this is just for the startup time. For example, if we have to go and connect to the VPN, the user execution has to be a lot more, like clicking on the sign-in screen, then we have to go and do some login process, then click on maybe the country, the P2P server just to connect it. But for all of this, we need a user interaction. So for that, macro benchmark library gives us the access of the device, and this device can be used to initiate the objects which we have. Find object can be used by text or by any other perspective. Let's say I just get the text of login and I can execute the flow. This is how we generate the flow for any user file. These all of the things is just a use case how we used it, but at NordVPN, what we did is what we'll discuss now. Just to run this part, we have to generate the baseline profile. That's a Gradle command, which we run. If we have a specific variant, the release variant or staging variant or Play Store variant, anything, we can use that. But the major concern should be here, we should always run this on the release build. For the devices, make sure to run it on the rooted devices. If you don't have a rooted devices, you can set up using the Gradle AOSP images. And all of these files which we generate gets created inside the baseline profile path. The file name actually looks like this, .txt file. It's just a text file, whichever flows, functions, or classes we want to optimize for. And that exactly is the user flow, right? That files which we have created gets shipped with the application to the Play Store. And whenever the user downloads and specifically starts that user flow, it gets that shipped, right? So this is the result which we have shipped. Now, at NordVPN, this is how the process works for us. Whenever we start shipping a release branch or the release APK, we create a release branch, we split it out. There, we trigger the CI for the baseline profiles. This is not done on each and every merge request. This is specifically done for the release branch. And then whatever has been generated, we commit this code and ship it to the users. That's the process. And whatever process we did, this was not a single person effort, so the entire team contributed to it. And if you want to see more what we did, we actually did a research with Google, and that is what the numbers were. That was listed with the developers.android.com, and that was one of the numbers where we fastened our login speed by 60%, and that's the QR code. Now, this was just a part of what we did in the implementation, but as we talk about the UI toolkit, we implemented Compose, right? So Compose was very new when we started integrating. Not new, but compared to what we had previously, it was a decade old. So this was very new for us. We just started implementing it, and we had to discuss what performance looks like. We are still in that same process of improving performance, but that's one step at a time. So to discuss what Compose works, there's a very niche concept of what recomposition is. So basically, whenever we initialize a specific screen, we draw something, then each and every function has its own parameter. So when the parameter, the data changes, when we redo the entire thing again. So this is a process or a loop which goes on and on whenever we want to draw something on the screen. And this will happen no matter what, right? But to make it performant, this is one of the things we learned. We have to use a stable parameter. And stable does not mean we have to annotate it with stable or something like that, but this actually means wherever composable functions you call, the parameter needs to be stable. So first, we have to discuss why we need it. Because whenever we have a stable parameter, the nested functions or the composable functions, if the data does not change, it will not recompose itself. As less the recomposition count, as performant the screen is. So we have to make sure how much stable we can make it. And that's a process which I would say never ending. We still keep debugging it to see whatever is being recomposed again and again. That's one of the biggest pain points we want to achieve right now, or maybe move out of it, sorry. Now, what is stable parameters? So whenever we discuss, we have a data class. We should all annotate it with val and not the var keywords, and that's a specific one. We should not pass collections or observers directly to the composable parameters, like list, maps, or even live data. we should avoid that. Or if we have to pass by any chance the collections or the list, because we always have a list of something, let's say the servers, right? We have to wrap it around with certain class, or there's a library of Kotlin immutable, which you can use it just to pass it and which will make that entire collection stable. This is something we started achieving and started working around with a certain point. This is how our wrapper class looks like. So we just want to create a data state collection where we don't want to pass the list of string. In place of list of string, what we did was we wrapped it around a data class and we immuted it with an annotation. We marked it at the rate immutable. What this does it makes sure that composable compiler knows that this is a non-stable, it's a stable parameter and it's not an unstable one, right? So how do we test each composables? And by the way, composables are the functions which the UI renders. So how do we test the instability or the unstability of the composables in any way, right? So there are two ways. One of the ways is very tedious. We have to keep seeing that whenever we run this, we have a layout inspector which tells us how many times each function in the entire screen has been recomposed. So if you have to see this, this is one of the code where whenever you start running your screen, it tells you how many times it recomposed. And as I said earlier, it has to be less to make it more performant, right? And you cannot keep doing it again and again. Consider a team of 20 people working on a certain code. And whenever they start doing it, not every person can go and check the recomposition count. So what we wanted was a report that explains the app compose code. We did not want to do it manually because we like to push it on the CI to make our life easy. And if nothing works or something does not want to work on our side, just move it to the CI, right? So that is what we wanted to do for the entire team. So this is a set of code we wanted to generate, and we wanted to set up a compose compiler report. That's a report which generates a certain set of data. Don't look at this. This is too overwhelming, even for us when we work with it. The important aspect to this is one block of code which tells you that we want to enable compose compiler reports, and wherever we want to set it or wherever we want to generate it, right? And this is the matrix which we want to generate in a certain aspect. These two are the most important aspects. Now, to generate again, we have to run our Gradle command. It also has to be run on the release build because the release is responsible of what we do, right? In this, if you want to run for a specific variant, you can just pass on the variant and we can move on. This generates 3 different files where there is a module class which tells you about all the classes being used in a composable function. There is a composable.txt. It just tells you all the composable functions we have. And then there is a CSV file, which tells you a report of the txt file just in a very formatted way. This is something which it generates. So for example, we have a server list function. That's all hypothetical. We don't have it. And this generates a function in which you see there is an unstable parameter. And the reason there is an unstable because we have a list of servers, which is we are passing as a function parameter on the server list. To fix this, what we can do is we can create a server collection, and then we can pass it there, and we can annotate it with immutable. What this will do is this will make the function stable, right? Or this is a tedious task again, because a lot of places we have to only pass the list. So for that, what we did was we created a generic data class wherever we can pass any type of list and of any type, and that we can pass directly. And this makes sure that we don't have to write this immutable data class again and again, right? Now, how we do this at the NordVPN Android side? So whenever we create a pull request, or rather a merge request, this was for some other text, but when we create a pull request, we want to run this compiler check on the CI because we don't want to do it locally. So when we run this compiler check on the release build of Android, this works as a reviewer for us. So it goes around the entire code. It goes and check if there is a unstable parameter. And just so that before implementing this one, we made sure that we stabilize all the composables so that from the next time, whenever this runs out, it only checks for the unstable which has been recently introduced. It generates a report on our GitLab, and it adds as a comment. And then it comments the PR or the MR for that, and it adds it. So unless and until you can resolve this out, this would not be able to be merged because this is adding as a comment, which is like an automated reviewer. We added more in details of what we wanted. And this is where we launched it in the Node Security blog. And yeah, that's pretty much it. Thank you so much. And I have some time for questions, I think. Yeah, thank you.
Hey, the cube is back. I don't know if it's working though, but it's back. Maybe we have some questions from the audience here. Yes, Paulas has one. I'm gonna try to catch it when I try to do it. Yeah, people are scared already. Okay. We're gonna pass it to you, okay? And you're gonna pass to Paulas, yeah. Okay.
Okay, testing. Okay, seems to work. Nice presentation, thank you. I had a question. So, does this performance testing and baseline testing, does it happen only in CI/CD, or does it also happen in some part on the actual Android devices when the application is shipped with, like,
We have been
production?
running this entire process in the CI/CD pipeline rather than maybe running it manually in the local machines. So everything has been set up. We have introduced KVM just to specifically run this part.
Okay. And basically, something like this is not running on the end user's device in the production, right?
No, so it runs on the CI. It commits the code into the before releasing the APK. So for the user, it's just a normal APK, but a lot of files have been shipped with that. So it does not impact any release user.
Okay. Nice.
Thank you.
Okay, any other questions? Christopas has one.
So how does it speed up the application opening? Does it do some kind of pre-rendering of images or text?
Yeah, so it basically works on the concept of ahead of time. So basically, the entire flow is also kind of a user flow where a user clicks the application icon and it opens a screen. So it generates that flow into minor files in the baseline prof.txt file. And that is the specific file we ship with the APKs or the app bundle. And that is where it ships the product.
Yeah, great, thanks.
Okay, any other ones? I have two in mind right now. Could we do it in other logic as well, like for connection, for data transfers and so on? Like the preparing it for being faster?
I don't know, maybe. But for the user execution, any flow where user is inputted, yes. But we wanted to only try for the critical flows, which impacts majority of the users.
Okay, and another one about the Jetpack. I understand this is a framework, right? That you're using right now. What are the alternatives of it? And is this the most performant one that Google recommends, or?
It was an alternative to the view system, what was decade old. Performant, I would doubt that, but it's the recommended one, yes.
Okay. So thank you for the great presentation.
Thank you.
Okay, the one and only Donatas, and he's gonna talk about the great story of Great Escape from EVS. Really curious to hear that myself, so enjoy.
Thanks. Great intro, I like the music a lot. Okay, so straight into, whoops, what the hell happened? The wrong button. Okay, so let's jump straight into agenda. So the story is gonna consist of 4 parts. First, we're gonna look into our stack and how it ended up on AWS. Then we're gonna look at the implementation on AWS. We're gonna look at the costs. We're gonna look at the reasons for migration, the architecture of the new infrastructure, and the execution. And finally, we're gonna look into the results and some gains that we got, right? So we first start with the stack. So in the very beginning, applications were sending their data using Google Pipeline. And it's a simple setup. And in a nutshell, it works like this. So we have Google SDK implemented on the application side. We then generate the event. This event is sent to Google Analytics, which is a high throughput queue. Then these events are being synchronized to Google BigQuery, which is a storage and compute node. And then we can visualize that data on Looker. Now, this is, this setup has its place, but it's not great for tracking user activity on the apps in particular. And in this screen, you see a sample event generated by this pipeline. The information marked in red is the information of interest, and all of the rest are just empty bytes that we paid Google for, and we pay when we read and write those bytes, and we pay for storage as well. So this setup is not optimal. So we wanted to change this. So meet the contender. This was the new pipeline that we chose. And this looks more involving, but it actually does the same thing. So we first generate the event on the application side. For that, we use mooselib, and this is a library developed internally at Nord Security by a low-level team. This event then lands on the API. We do some basic validation of the event, and this event then is sent over to Kafka. Kafka is the equivalent of Google Analytics in this case, so it's a high-throughput queue as well. So it serves like a buffer, and we keep data there for some period of time. In our case, it's 1 week. Then we read that data using Spark. Spark is a compute component. It doesn't have any persistence, right? So we have to write that data somewhere. So we dump that raw data to Min.io. Min.io is the equivalent of Amazon's S3. And yeah, we have a bucket for raw data. Then, as I mentioned, that raw data disappears from Kafka after some time. So what do we do with that raw data? We read it again with Spark, and then we enforce schema. We make it production ready, so to speak, and we then store that data on Min.io for safekeeping again. It has a separate bucket, sure. So we have raw data in case we need to reprocess that, say some mistake happens, something like that. Now, once we have that production data, it's ready to be used by the analysts, right? And this data can be exposed through Tableau. And Tableau is using Dremio and Spark as its engine to read the data from the persistent storage. All of that is being taken care of by Airflow, which is the orchestration service. And it basically ensures that the jobs run at a certain time. And if they fail, it knows whether it should retry it and stuff like that. Now, we had to run this somewhere, and we went with AWS. And there were very simple reasons for that. So for one, since we changed all of the components of the Google pipeline, especially in particular, we changed the generator of the events. So we now have a completely different structure. And for that, we don't know the workload, right? So for that, some on-demand resources would be nice, because we need to experiment. We need to spin up some servers, tear down some servers. And cloud environments are great for that because they have that functionality. The other thing is the absence of any binding agreements. So on AWS, you pay for the resources that you use. So we don't have to inquire any costs, as say in the physical data center where you order some server and you have to pay for the whole month, as an example. So it's nice because we can experiment. And last but not least, so core admins, they had prior experience with AWS, and they offered us a helping hand in setting everything up for the first iteration. So when it comes to implementation on AWS, we have this pipeline, and I'm showing you the end result of it. Of course, there were some multiple iterations. So API is running on EKS. And this is a Kubernetes service that is being maintained by Amazon, right? But all of the rest, those were deployed on EC2 instances that had EBS disks attached to them. Why? So for one, we have control over the setup because we can scale compute and storage individually, right? We can encrypt the contents of EBS, so Amazon wouldn't know what kind of data we store there. EBS is also cheap and fast compared to S3, as an example, because we don't have to pay for the data we read or write. So analysts can run as many queries as they want, which is great. And lastly, this setup is kind of basic, but it was intended to be that way because we can easily move this to some other provider if we choose to. So, and it proved to be useful in the end. These purple circles, these mark the ownership. So that core team I mentioned in the beginning, these services were running on their sub-account. And in the beginning, we didn't have any control over those services. Accounting was kind of difficult because we were using tagging to separate the cost and stuff like that. So after some time, it was decided that it would be best for us to have our own sub-account. And the first service that we migrated to that sub-account was Min.io. After that, we deployed Dremio on our sub-account, and then the rest followed. And because of time and the resources limitations that we had at the time, we did not migrate Kafka, but it's still something on our list, and we're going to do that eventually. How did it go? So this is the monthly costs graph on AWS. And as you can see in the beginning, we had 0, because on our sub-account, we didn't have any services running. So AWS handover took place, and we started accumulating the costs. This adoption of this new pipeline is also growing, but at this moment, we are maintaining 2 pipelines. So we're maintaining the Google one, and we have the one on AWS. We're still experimenting with the setup, as you can see, but at some point, we are happy with what we have, and then we announced the sunset of Google pipeline, right? And then this happened. This is the actual sunset. So at around January the 1st, 2023 was the hard deadline. So as you can see, developers were busy sending the data they were sending to Google. So we were expecting some increase in the inflow, maybe not that steep. But the good news was that that setup handled this increasing load. But since we can clearly see a trend, we now have to either optimize the setup or do something else with it. Now, optimization would mean that, of course, a lot of data was just trash because the sunset was a hard deadline, right? So not all of that information was of use, but at that time, we did not have concrete business requirements on how to aggregate the data, what's the essential data and stuff like that. So we decided that we're going to keep this thing as is, and we're going to focus our efforts on migration. And we had a new architecture at around June 2023. How did it look like? So as you remember, these were the services that were on our sub-account, and these were the services that we were migrating. And what we wanted to do, we wanted to have separate environments for Min.io and Tableau. So these would get their own physical instance, because these services are very important. So Tableau is user-facing, so we don't want anything interfering with that. Min.io is also crucial because it contains both raw and the production data. As you can see, that H symbol there, so we went with Hetzner because that provider had the best pricing. Now, a story is different for the processing services because it's the busiest part of the pipeline, right? So the analysts are running queries there, the jobs are running there, so things are changing. So these services got a dedicated instances as well, but we have Docker Swarm running on those instances because we wanted to have the ability to reallocate the services between the resources between the services if we choose to. And in addition, we have Hetzner Cloud Machines to join the party in case we have some increase, some unexpected increase in the load. And of course, I'm oversimplifying everything with this drawing, right? It's actually a lot more involving. This is a high-level drawing again. The difference here is that the data inflow and the processing flow is still the same. But as you can see from this graph, we have high availability because these services are split across 3 data centers. And there's actually more, even more, right? Because we have to figure out networking, we have to size the servers and things like that. And Daniel was the one working on all of these questions. So he was the solo man in this project from the beginning, and he was the one participating in the whole AWS handover, right? So he was working on this new architecture, and there's only so much a single person can do. So he was joined by Dennis in September 2023, so they could actually start splitting the daily tasks and do some actual work on the migration. And the things really took off when Arnas and Alex joined in, I'd say, late January, because they joined like 2 weeks apart. And this is when they, they went through the newbies day, they had some pizzas, and the next day they're busy working on this migration because the hard deadline is March 31st, 2024. And needless to say, they delivered because I have those pictures here, so they passed their probation. So what did they have to do? how do we go from this to this? So in this slide, you see our AWS account on the top and the Hetzner one on the bottom. So in the very beginning, we have nothing on Hetzner. So we start with deploying the machines on the Hetzner side, provisioning the servers on the Hetzner side, and then we deploy MinIO service. We start synchronization of the data between these two environments, and the end goal is that MinIO on Hetzner contains the same information as the MinIO on AWS. Then, since we have a lot of data to move, and it's being done over the internet, we have some time. So we deploy Dremio and Tableau. These services are doing nothing at the moment, but they're waiting for their turn for the switch. After that's done, you remember we have these two buckets that I mentioned. So that's one for raw data, and the other one is for the production data. So we then synchronize the production data bucket, and then we instruct Spark to write this production data to MinIO on Hetzner. At this point, Tableau on AWS it contains outdated information because it cannot read data from MinIO on Hetzner. So we then back up and restore Tableau from AWS to Hetzner, and then we make a switch. So the end user is now looking at Tableau on Hetzner, and he didn't even feel the switch because it was a simple change in the domain. And we call this migration online migration because it's from the end user's perspective, right? So the service is in the middle. What's nice about a setup is because we can shut down some of the services for a brief moment, right? But we can, as long as we control the end user environment, all is good. So the last part, and we keep the setup for quite some time. So the analysts are working on their queries. Everything is smooth. Now we have to move data engineers who are working with the raw data mostly. So for that, we have to stop Spark on AWS. We deploy Spark on Hetzner, but it stopped because we're synchronizing the raw data between the two environments. And once that's done, we deploy Airflow and Spark, and we are resuming the ETLs. Now, at this point, as you can see, these two environments are disconnected. We still have raw events coming from the apps to the AWS side. So what we do next is we simply decommission MinIO, and we deploy an EC2 instance that serves as a proxy. And this facilitates the communication between Spark and Kafka. And this closes the loop. Basically, we now have a working setup. Now, the problem with this EC2 instance, we actually had the most problems with this actually because we inquired the data lag. The processing was not that fast over the internet, but it's a separate, it's an involving topic, and I would need another set of 20 minutes to explain what the guys did, but it's something for the future. Now we're getting back to the costs timeline. So what happened next? Of course, it escalated. And at this point, we get the Hetzner account, and we start data tiering. This actually has nothing to do with the migration, but it's something the guys had to do in order not to blow AWS costs even more. So we moved some old data to Hetzner. So it just postponed the migration works, not made them faster. And this last lump on the graph, these are data transfer costs that Amazon charged us. So for every byte that we sent over the internet, we had to pay for that. And we denote cost savings as the difference between the monthly cost on AWS before the data transfer costs to the ones that we spend now on Hetzner. So what did we gain from this? So you remember that number X for cost savings. So we got 7X. So we reduced the cost by 7 times, which translates to going from around 73K a month to around 10K a month, and that's respectively around 900K a year to 120K a year. We got more resources and more recent ones. So as an example with storage, we got 3 times the storage for that money, and that storage was around 10x faster. Same story with CPUs and RAM. Now, the reason for that is because we got to choose the hardware ourselves, right? And that hardware is more recent. In addition, we don't have any virtualization overhead that we had on AWS. In addition, since we have full control over the hardware, we can encrypt both the boot and the root disks, which is nice, and we went for that. Since this whole setup is located in Europe, and the guys who are working with that setup, we're in Vilnius, so the latency is better. So for those people who do their everyday work, it's an improvement. And lastly, we have true high availability because these services now are spread across 3 data centers. And it's something we didn't have before on AWS because AWS has this thing as availability zones, but those are expensive because they charge you for the transfer and network transfer cost as well. So we didn't have that on Amazon. What is the setup doing at the moment? So in this graph, you see the data inflow for the past few months. So again, like the inflow depends on the quality of the release. So things happen, right? So we get more data, we get less data, but on average, I'd say that the inflow is around 200 gigs of data a day, and this is only for the data that comes from the applications. We have other sources, but to deal with this particular load, we allocate at around 30% of the cluster now, and the rest of it is used for any transient workloads that we encounter or some ad hoc things that the analysts are doing. Before we get into the takeaways, a question to the audience, and I think Marius can arrange a prize for that. So a pop quiz. What did we get for 5K a month on AWS?
Anyone wants to try to answer it?
I can give you a hint. So I showed this, like the answers in the slides. It's the last service that we have on AWS at the moment.
Do you remember what it is? That is?
EC2 instance proxy.
Yeah. It's this little thing, which cost us 5K a month, and that's half the whole pipeline cost on Hetzner. Most of that, most of those costs are data transfer costs, again, over the internet. Amazon charges us for that. The rest of it is the cost for the instance itself. What am I implying? So am I saying that Amazon is somehow bad? It's expensive, but it's actually great, right? Because if you're dealing with some sort of highly dynamic workloads, like think APIs, or you have some niche service like CDNs, it's really hard to do like CDNs. Try that on Hetzner, right? So you wouldn't even you wouldn't even stand a chance compared to Amazon. I'm not saying that Hetzner is the only answer as well, right? So there is no silver bullet, and we should think of our projects not as projects, but as sets of workloads, right? Because every workload has its own optimal setup. Now, I'm mentioning that because during the hiring process, we had people who were turning down the offers of joining the team I showed you before, because we were pitching them this project, and we would say, like, it's so cool, we're moving away from AWS to the physical data center. And the response would be like, but the industry is going the other way around, man. Everybody's migrating towards the cloud, not away from the cloud. So yeah, that's what I mean by that. Maybe your project needs a hybrid solution, and that's perfectly fine. And last but not least, you should build with portability in mind, because if you have that, you can take advantage of this highly dynamic and competitive market. And if you need, guidance on what's available, you can just reach out to the infra's procurement team. We have lots of contracts with different providers, and I'm sure that you can find something that will suit your needs. And I encourage you to check that out. Maybe you can save even more money than we did. Thank you.
So, do we have any questions for Donatas? Yes, we do. Paulas again. Wanna try to catch it? Yeah. Waba! Almost.
Okay. Thanks. Nice presentation. So I have kind of a compound question. So first, do you know what was like the price for the Google Cloud and when you were using it in comparison to AWS and like your host?
Sure. So for Google Cloud, it's complicated because we could easily separate the costs for Google Analytics, right? And the cost for Google Analytics alone was 20K a month. For BigQuery, it's a bit more involving because we have other teams using that thing, so it's not that simple to separate those costs. But from our estimates, that was around 200 something K a year as well.
Okay. And then the compound question is, since like our infrastructure for querying and interacting with data that we have is kind of now cheaper, maybe there's going to be a possibility for the library, like Leptalo library and so on produces its events. Maybe there's going to be a possibility for us ourselves to write some queries and interrogate the data instead of just working with samples and needing a huge turnaround to actually understand what's going on.
A sneak peek into the future presentation, maybe. So the guys are working on a solution similar to what you have for staging data in Grafana. So they're working on a solution built on top of OpenSearch and Kibana. So we're going to replace the Grafana solution with that in the upcoming future. And as well, we're going to allow the developers, we're going to basically reuse the same solution for the production data. So you will be able to send arbitrary payloads, and you will be able to debug production code live.
And the ability to get like just ability to query the
API
data
access is going to be included, yes.
Okay, thanks.
Okay, great question. Really cool ones. Any other questions from the audience? Darius, can you pass the mic? Guys, help Paulas to pass the mic.
One. So I saw you have like 3 data centers, right? And all of them in Hetzner?
Yes.
So let's imagine a nightmare scenario. Hetzner goes down for some period of time. What's your plan?
So the guys are working on a backup solution as well. At the moment, we don't, like, it's a young setup, so we don't have everything figured out at the moment. But this high availability, it's not the same data center, so these span over different countries. So unless Hetzner goes bankrupt, like, we should be okay. I hope, you know, all of those data centers are not going to be nuked in one go. Maybe it will take turns. And we'll have some time to migrate again. It's still a portable solution, so like we're gonna just repeat that because, as you saw from the presentation, we migrated this thing roughly 3 times basically because we changed the services that we used and stuff like that. So.
One more. How long does it take to migrate data?
To move to synchronize, you mean?
Yeah.
Ooh, what was it? A month? Yeah, so I'd say that it depends because the throughput wasn't consistent. So like one day we would be like, oh, like it's gonna be we're gonna be done with it in a week, and then the week passes, it's still synchronizing because the throughput is now down. So the guys had to come up with clever solutions by setting load balancers in different places and stuff like that to trick Amazon to not to throttle us and stuff like that. A separate presentation, I guess.
Yeah, that would be really interesting one, the data moving. We have one question from Slack. Thomas is asking why Airflow is needed. Spark structured streaming should eat up Kafka topics perfectly fine, ? Or do I miss something?
Sure. So Airflow is taking care of all of the jobs, right? So we have other jobs that are not streaming jobs. So, but we do run streaming jobs through Airflow as well because we need a place. It's actually Spark streaming. When you in the beginning when we were testing that out, it's very difficult to track the status of that running query because if you run that through like things like systemd, it crashes, but the process doesn't exit. It's still running, but it's not. It's like Spark is weird in that sense. So. We came up with a solution that would run these streaming queries as batch jobs. So it would just start from the last offset. So it's like an incremental batch job. So it's still streaming.
Nice. There are some more questions in the thread. Check it out after the talk. Thank you, Donatas, for a great presentation and great journey.
Thank you.
Okay, we're gonna have a small break. We're gonna come back at 3:20 and deep dive even more. Okay, welcome back after the short break. And as you can see, I'm not the only one on stage right now. We have some special equipment that Amanda's gonna talk about. And the story is here not only about the WinApp build server, but the story is about going from GitLab to GitLab.
Hello, everyone. As introduced, my name is Amandas, and I'm engineering team lead at NordVPN Windows team. And today, a story about many migrations that happened in our team, and we still ended up at the same place, GitLab. So let's jump into the agenda. So today, it's going to be just a history lesson. Of course, I don't want to scare you guys. There's a lot of memes, there's a lot of pictures, so you will not get bored. So we'll talk about our infrastructure in 2019, hint, hint. But we'll also talk about our amazing plan, how we thought that we can make it better, and we'll see what we have now. So let's jump into it. Our infrastructure in 2019, and ours, I mean Windows, NordVPN Windows team. So it wasn't much, but it was honest work. Everyone was pitching in, but as some people would call it, our infrastructure looked something like this. And you may ask why. Well, we had this build server. This was the only thing that ran all of our infrastructure, all the GitLab pipeline for NordVPN Windows and also NordLocker Windows, because they didn't have their own at all, but they told of NordLocker. And, you know, it also was the only runner that was capable of signing Windows binaries for releases. So it was crucial part of our releases and in general day-to-day work. So why Potato? Well, it wasn't actually that good. And additionally, as I mentioned, it was able to sign binaries with this physical key, which is actually quite a painful small item, because due to this, we had to keep it always unlocked, always having monitor plugged in, and it had to run in interactive console mode, so it wasn't very stable, to say. So our team members had to go to the server room, which was quite messy at the time, and had to basically restart the runner at least once a month, sometimes happening even several times a week, because someone would trip over the server, someone would just plug out that monitor and it would instantly stop working. And additionally, you know, maybe someone like me would just plug out the internet out of the computer and it would also stop working. And not just that, not just this bad boy right here, but also we were using a GitLab for everything. And by everything, I also mean issues. You know, like product management was very happy creating issues in GitLab. And, you know, we thought that we can change all of that. We thought of an amazing plan, and we thought we can upgrade our infrastructure. We can upgrade to something better than GitLab issues. And with that, we thought of introducing Azure DevOps, a new platform that was having way better Azure boards, so no more annoying GitLab issues. It had awesome Azure pipelines, new runners set up in a different machine than this one. And it also had integrated artifacts solution. And as your Windows team, it was made by Microsoft. So it felt like a home. And we started migrating everything. Issues, documentation, repositories, anything that you can think of. But we hit some blockers. And do we have anyone who has an idea what we hit? No? Well, we hit Jira. So after migrating all the tasks, we had to migrate them once again. Because Jira happened, and the same goes for Confluence, and all the documentation and issues were once again migrated. And we were left with only repositories inside Azure DevOps, and only those that we were able to migrate, and they were not all of them. And why is that? Well, the bad boy in the room wasn't very happy, and it just decided not to work with Azure DevOps runners. So no signing capabilities on Azure DevOps meant that no crucial application that was NordVPN Windows could be in Azure DevOps. So, and as it was unstable as it could get, we just didn't want to bother more, so we stayed with crucial repositories in GitLab until we someday resolve the issues. That never happened. And what happened was much worse, and I'm very happy that we didn't migrate everything, because this happened. The server crashed, and a lot of people still don't know about it until now. Yeah. Okay, so it wasn't the main server. It was the one holding all the runners and whatnot, so the main VM was safe. We were already, on our toes, thinking that this can happen to the main VM, and we could lose data because the picture shows a pretty good situation because we didn't have backups at all. So yeah, that happened, and additionally. Already, as I mentioned, we had Jira and Confluence. We also had Black Duck and Checkmarks initiatives. And those also brought some more things on the table because as GitLab was and is the main platform for the code, all the integrations and all the helper scripts and whatnot were made in GitLab. So just to have everything done in Azure DevOps was additional hassle that we didn't want to bother with. But there was one last thing that kind of pushed us forward to it, to just dropping this amazing idea. And it was Cyber City migration. In the picture, you can see me, my manager, and the bad boy here. We had to migrate it to the new office, which brought a lot of different cool initiatives, like not having Ethernet at your table, or being able to run some automation tests by leaving your computer unlocked at your desk. So we had to step up our game and migrate everything to work properly without having to go there every week to fix it in the server room. So this happened in 2023, quarter 2. And this was the first quarter that we've mentioned that we need to do some migrations back to GitLab. We thought, okay, there isn't too much of things there. We should be done in maximum 2 quarters. We will set, okay, 1 quarter and just some leftovers. that didn't happen either. So some numbers. We had 55 repositories in Azure DevOps, over 6,000 Nugget packages, 50 employees that would feel a mistake that we could do during the migration. And the most important part, we had 0 DevOps engineers in our team. But even those numbers do not reflect how much effort we've had to put, because we underestimated how much we had inside those repositories as well. The pipelines were quite custom to Azure DevOps, not an easy feat to migrate back to GitLab. So just for that sole purpose, we had to create separate PowerShell scripts repository that we wrote from scratch just to support all the functionality we were bringing back. And even now, we still have some technical debt. Sorry, guys. And even QAs and POs were pitching in to help with the migration, so you can understand the lack of resources we had. But finally on March 5th of this year, we killed Azure DevOps. It took us a year. Not that one quarter that I mentioned. And it was quite challenging. Of course, it wasn't like full-time working on it, but it definitely required a lot of patience, a lot of strategy, and just working together as a team, because nobody knew exactly what they're doing. They just knew, okay, we need to go this path. And we were successful. We didn't lose any data, and everything is now in GitLab, more or less. And Azure DevOps is dead. And now let's take a look at infrastructure now. So first thing, well, maybe not infrastructure, but people. So we added 2 DevOps engineers to our team. So they're taking care that we're not getting into such mess once again. So yeah, thank you guys. And something that I'm very proud of is now we have 4 dedicated servers running Proxmox here in Cyber City, and they're stronger than ever. And for example, now GitLab signing runner had over 4 months of uninterrupted uptime, which was like, as I've mentioned, at least 4 times better than you used to have. And in addition to that, you don't need to go to the server room anymore. You don't need to sweat there due to the heat because of no AC there. And yeah, so it also brought that possibility to connect to it remotely. So this is probably for infrastructure people, it's sounding like this is basic stuff. But for us, it was a huge milestone and a huge change to our day-to-day development lives. So let's jump into 3 takeaways. Of course, with this whole year project, there could be way more of those, but just wanted to take those very basic and things that we usually forget to do. As so validate your ideas. Before doing any major changes, actually check what's possible and what's not. So we had a lot of problems, like as I mentioned with signing and other stuff that just instantly said you're not migrating completely to Azure DevOps. Additionally, you need people to maintain the infrastructure. You know, as tech people, we love new shiny things, and we forget that we will need to maintain it. And last but not the least, team goals versus company goals. Jira, Confluence, checkmarks, Black Duck. Hi guys. So yeah, they brought also a lot of things that made us make the switch back. And just as last note, I would like to give 12 points to SRA team for accepting us into Nexus, IT team for helping out with the servers. They did wonders, and now they're running very smooth. Gytis Morauskas for trusting me with Azure DevOps and with killing it. And to my sometimes impatient NordVPN Windows team. Thank you.
Okay. I have a lot of questions about this one, so honestly. Like,
I skipped
what
the part
the hell?
with CTOs.
Okay, this is the true SB key?
No, this is a new one.
Okay, I just was freaking out already. Okay, another one. What the hell? How did you came up with the idea to go to the Azure DevOps? What was the selling point? You drank beer with them, or what happened?
Well, I wasn't there at like when the decision was made, but I think we just got in love with Microsoft too much.
Yeah, happens. Okay, any questions from the audience? Jakub has one. Gonna try to catch it? Yay, let's go. Awesome.
Okay, so did the monitor need to be connected to the PC because of the ring and remote access separation in Windows, and you couldn't run GUI apps on the remote machine, or was it a different problem?
Yeah, so the signing certificate has a lot of security measures, and one of the things it requires is local session.
Okay, so it's probably not relevant at this point to you, but you can escape this ring separation in Windows by running the scheduled task from the scheduler. So you probably won't use it, but I know the pain and I share with it. I worked on something similar.
Yeah.
So yeah, it's horrible.
Jakub doing Jakub things.
Yeah, so I can at least expand a little bit on what we're using now. So on Proxmox, there's no VNC, and it's just a local session. So we just bypassed the problem that way.
Okay, any other questions? Paulos, you have one?
Yeah, just a fun one. Will you encase it into epoxy and make some kind of memorial out of this computer?
Marius?
I don't know. It's your stuff. You can do whatever you want with it.
I believe that it was still belonging to everyone. I think we could do something like this, and somewhere put it in Cyber City Museum or something.
Yeah, we have that already. We have some computers and. Any other questions? Christopher.
Thanks for the presentation. It's not really a question, just a comment. So when you guys were using the Azure DevOps, some time ago I needed to access some code. And I asked the guys to give me access, and they sent me a username and password that they generated, I think manually, and the HTTP URL without SSL. And I connected to it, and I was like, where is the HTTPS? It's not working. And I was told, yeah, it is how it is. So yeah, that was fun.
You want to comment on that, or just skip it, Mimi?
At least you didn't get the password, which is capital city .1234.
Yeah.
Okay, I don't know what Ramunas is thinking right now. he's just gonna go silent, I guess. But yeah, thank you for
DevOps is dead.
Okay, thank you for the great presentation and this bad boy. And next we have Davidas. He's gonna talk a little bit about the fake leads. I don't know what the hell is gonna be, if it's gonna be technical or not, but yeah, welcome Davidas on stage and have fun.
Hello everyone. So thank you for having me here. I'm quite excited to talk about fake leads and what is the fake leads and what kind of problems we had with it. First of all, the question for the audience, who was playing a game, multiplayer game Among Us? quite a lot. So yeah, first of all, let's start with what is a fake lead in Agenda, then what is the problem we're solving, how fake leads, I can call them imposters, how they work, and how we are solving and we can solve this problem. So fake leads in general is the old inquiries who are coming from website forums or registrations with the fake emails like non-existent domains, non-existing emails which are not able to reach them or to contact them, then inconsistent data, for example, messages like blah, 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 whatever, fake phone numbers or old zeros, etc. Duplicated IP addresses for the query. So if there will be scenarios when, let's say, 20 inquiries came from the same IP with different content, and we know that it's not real because they are not reachable. High risk geolocations like India, Pakistan, Russia, etc. And all other information you can enter, let's say address or I don't know, business address or business name and so on. So what the problem we are solving, sales team was coming to me and they're saying that we are getting a lot of inquiries with like, looks like it's okay, but they are not reachable, they are not replying, and there are quite a lot of them. So for example, this is a message, offer perspectives on the significance. I don't know what it's about, but they were reaching through the norpass.com website, and a lot of them were coming. So we have an imposter. How to catch it? How to figure out which is the one? And what is the main problem for the businesses is, first of all, is budget impact. So we're spending money on ads, and through these ads, these I can call imposters are coming and trying to fill out the fake forms for some reason. We don't know yet why. Waste time and money. So there was a team in the sales who was doing manual job to separate the fake ones with the real ones. So we are wasting a lot of time and effort and human resources. Damaged reputation. This is quite interesting one because there were times when we are sending and trying to sell NordPass, our product, and these people were coming back and saying, I never seen your product. First time I hear about the NordPass. Why are you texting me? So we figure out that these imposters got a bunch of leaked email addresses and they were sending forms with these emails. So it can damage our reputation quite badly. And data discrepancies is when you're collecting data from these forms, where they're coming from, what kind of inquiries. And by this data, we are figuring out where to send this more money to which platform, I don't know, Google, Facebook, to advertise our product and to understand how we can sell more of these products. So now I'm going to the most interesting part for me. How they work, how these imposters works. So I have one most favorite one is API-based bots. So this is the script I wrote in Python. Just a disclaimer: this website owner knows about it, and I can tell the name is one of the startups in Lithuania where you're putting car ID address and you can see a whole history of the car. So I wrote the script, I released it, and it goes like 1 per second fake leads subscribing with, you see the emails, kgmail, fgmail, ygmail.com, and they're going through. Then there's a second one, which is not really popular, but Selenium-based bots. So also I wrote the test to fill out the forms and to submit the form. So this video is quite long, but what I did, I found one website on the Google. It's called LastPass, and I tried to fill out the forms automatically, and see, it went well. Goes to a thank you page. This script goes to back, then fills out again, and so on. Haven't done a lot of stuff there, but still works. Click farms. This is the most popular probably in this Pakistan, India, Russia, and everywhere is high cyber criminal countries. So this one image you see, this is phase one, where there's a lot of devices connected and one person just clicking through ads, through, I don't know, downloading apps, so increasing the number of the popularity, and people are paying for that. So then there's a phase two, where a lot of devices connected into one server, so we can put on the server one scenario and it repeats through all phones. And then there's a more advanced, where there's multiple servers connected, phones, tablets, with virtual machines, and one person is just managing them and doing quite good and bad job. And this image is quite funny because this is two guys from China went to Thailand, bought about 500 phones and 30,000 SIM cards. And in this flat in Thailand, they were doing click farm business, as I can see. And they were catched. And in the end, they've got not only, maybe too rough word, but they've got 5 years in prison just for illegal work in Thailand because they didn't have permission for that. So you say, okay, how can solve this problem? There's a CAPTCHA, works every time, amazing. No, we have CAPTCHA solving service. You can't believe, but this one service is offering to solve 1,000 CAPTCHAs for $1. Sounds quite good. But then we found out that there is this message which says that, oh my God, these people are feeding their families, they're feeding their lives, and instead of working in toxic factories conditions, they are working on the computer. And you can see on the image that this anti-CAPTCHA Superman is feeding this guy on the computer, which is quite amazing. And we were like, what the is happening? Is it real? So then we decided to build a fakely service. So we thought, okay, when submitting the form, we need to filter these forms, basically emails, and we connected Never Bounce API. So Never Bounce is a tool which checking domain is existing, the whole email exists or not, if it's bouncing or not, and we thought we are the winners now. Now we found the imposter, everything is great. But now I see that not. There's a lot of fake leads, even more than valid ones. What is happening? So then we changed the concept. We changed that structure. So first of all, we were checking syntax, then filtering temporary emails. There's a bunch of temporary emails where we can create an email for 1 day, for 1 hour, and you can send emails and looks like legit. Filtering blacklisted domains, so these domains are in our basically database. Then there was an issue that, oh, maybe there is a problem with subdomain emails, subdomain emails, right? So for example, info@staging.nordpass.com. Then we added an option, so to pass them or not. Then there was an issue about the numbers in the domain, so nordpass23.com. Also, maybe that's an issue. And in the end, we're checking with the Never Bounce, the same tool, and then we're sending to Salesforce. And okay, now this is everything we can do, and let's see what's happening. So now you see the blue column is the actual leads, and the yellow is the fake leads. And this graph with the percentages, you see that there is no actual change, a lot of fake leads still going on. Then we were thinking, okay, what we can do. So I decided to collect all this data. So payload, to collect the payload, to collect which emails are successfully going or not. And we thought we're going to collect the data and we understand where these guys are coming from, what they are doing, which are the most bad ones, like blacklisted domains or temporary emails or syntax, and etc., just to have data, because we had in mind that we're going to build from this data a machine learning model, which in the future, by learning this stuff, will decide is it fake or not by himself. And then I came to my sales people into marketing. And I said, okay, can we check where these guys are coming from? And I put an Excel of where they're coming from, and it looks like it's Google Ads. And we thought, okay, that's interesting. So Google Ads are sending fake leads and fraud traffic to our website. What is happening? So what we decided to do is to disable Google Display Ads. Google Display Ads is where random website can put the widget on the website, and they're Google showing your advertisement on there. And what we have, 0 fake leads. So okay, we then checked Never Bounce tool. Everything's going down, way better, and that's it. So then we contacted Google and we said, okay, this is the fake leads are coming from your side, guys. What's happening? And they answered that yes, this is our problem. You found that issue, and they gave us the money back in the credit. And still, I think they are trying to figure out how to solve this, because they were sending ads into domains which domain rank was equals to 0, which can be, for example, our nordpass.com domain is equal 80% of 100 or something like that. And then I did a larger research. What is happening with this fraud, networking fraud, income, and all the fake leads? So I found that in 2024 so far, TikTok has the most channels going to click fraud and fake emails, and Google is just second from the bottom, which is very interesting actually. And then we have that 22% global ad spend was lost due to the bot fraud. 27% organic and direct traffic is basically by bots. And $1 of marketing budget is lost to ad fraud for every $3 spent, sorry. And currently what we have is we are collecting still data. We are having way less numbers, and we are still collecting data, and we are trying to, in the future, we will try to create some machine learning module to be able to use that on not even on the contact forms, but also registration pages. We have that actually service available for whole NordSec, so our plan is to share with everyone who wants to use it and who sees the needs of it. And yeah, that's my whole story. Not much technical, not much funny, but this is the problem we have, and probably you can check that a lot of business have this problem also. Thank you.
Thank you, David, very much. So maybe we have any questions? We do. Again, Paulas is again.
I'm closer this time.
Yeah.
So did I understand correctly that that basically fake information comes from ClickFarm, which clicks the advertisements for the Google, and then we send like fake data to you, right?
Correct.
Okay. Isn't it also like an interesting business opportunity for like other, if we have a good enough solution, maybe we can provide that to other teams, and it could be like kind of privacy adjacent.
Yeah, that's what I was saying in the end, that our goal is to share with the whole NordSec, or even to create a separate product for other businesses to use it. Not that much people are talking about it, but there's a lot of articles about it, and I think that's a great thing to use for our company as NordSec, and in general, maybe we can create a separate product as a security thing to avoid these fake leads.
Yep, thank you.
Nice. Any other questions from the audience? Okay, so I have one then. So what's the response from Google? What's the official response? They're gonna figure it out?
They didn't say that they're gonna figure out. They're gonna say that they're gonna do the research. But they said that we found an issue, and they gave this money back, and they say just to wait.
Because it's kind of beneficial for them in the way as well, right?
Of course.
Yeah.
Of course.
Yeah, makes sense. Okay, I see. So thank you, David, for the great presentation.
Thank you, everyone.
And we're going to come back at 4:15, so we have around 20 minutes of break right now. Just a reminder, there is a quiz. You can win a really cool t-shirt. If you didn't try already, do it. Only 5 questions. Some geeky, some not so much. So yeah, see you in a bit. Okay, and we are back. 2 presentations left to go, and then we're gonna hit the gym, right? The gym. It's called Sparta, as I remember correctly. Okay, let me introduce you, Agnes. She's gonna talk our journey and our patent portfolio, and we're gonna, I don't know, figure out something new, I guess. So, Agnes, enjoy.
So, hello, my name is Agne, and I'm from patent team at Nord. So a lot of you might wonder what our tiny team does in this company. So to put it in short, we work together with our other teammates from the company, and we try to identify new ideas and emerging technologies within the company itself and turn them into patents. So let's dive to beyond the product to the value of Nord's patent portfolio. Okay, so for the agenda, we have several steps. So we will start with how patents can drive the progress and what the kind of value points do they bring to the table in general. Then we're going to move to challenges that we faced at Patents Playground. And on the second part of my presentation, we're going to review the Nord patents in general. We're going to go through portfolio and numbers, the technologies we have patented, and of course, the edge of it. And at the very end, I'll give you a few key takeaways to bring back home with you. So let's start. No patents, no progress. That's a very sound phrase, to be honest. But just imagine, you wake up one morning and you don't have your smartphone in your pocket. Also, your electric vehicle does not exist anymore, and you don't have any light bulbs at your home. All of these tiny inventions that came to us through the years have one tiny element in common, and it's a patent. So companies invest heavily into research and development, but without patents, it would simply just be a gamble, you know? So I would suggest you to think of patents as a 2-factor authentication for innovations. It's really annoying to set it up. It takes a long, long time, but at the end of the day, it's totally worth it because it secures your hard work. Okay, so what kind of values do patents bring to the table? Of course, at the very beginning, it's the shield of innovation. Because once company gets their ideas patented and, of course, granted, it gets the exclusive right for it for 20 years or so. So that means that nobody else can use this idea, well, at least when the company lets them to use it or license it or monetizes it as well. So another thing is that when you are trying to get a patent, it takes a significant time and it takes significant resource to do it. So once you get a patent, it's actually a thrill. We feel happy for the inventors, we feel happy as a team as well. And it also comes as acknowledgement from the government executives, not executives, but examiners and the authorities. And it says that your idea is actually valuable, it brings something to the table, so you feel, I would say, legit. You would have like a blue check mark, like you have one on Twitter or now so-called X as well. Also, it fuels the competition between the companies, you know? So it enhances fair play because you cannot use the same ideas that other companies have patented. And I know that some of you are skeptical, and you'll be like, yeah, Agna, patents are cool and whatsoever, but imagine if we could give our ideas and just use them freely. We don't need patents anymore. Like, what should we do with them? Okay, just let's go to an example. You should imagine that you're creating some cool car or a phone with some cool features or whatsoever. And you put your heart, you put your work, you put your soul into it, and it's basically your baby. You're so proud of it, and then a company, like another company, comes in, copies your idea, and sells it for cheaper. Well, it can sell it for cheaper because they didn't have to invest their time, their money, or their any resources into it. So they can sell it just simply cheaper and maybe even faster sometimes. So it's basically if you're creating, not even creating, if you're perfecting some kind of a cooking recipe at home, your neighbor comes, tries it, copies it, and then opens a food truck right next to you. So it's pretty annoying, isn't it? And imagine that if your idea could be easily copied, there would be lack of creativity. Like there would be no point of creating something new. So we would be stuck with the same smartphones, with the same features, and life would be just boring, I would say. The other thing that is also there that I forgot right now, but I will mention it later probably, and I remember it, so it's a really good thing. The patent actually acts like a referee, like a tech referee, I would say, and it ensures that the match is fairly played. So it reviews if you use others' ideas as well, so companies cannot use it, and etc. etc. Okay, so as every single playground, we have also a patent playground. Sounds funny, sounds also fun as well, and we also have trolls there. And trolls are funny creatures when you think about it. I will also give you another example that you would have to imagine it. Once again, you and your team, you're creating something great. Some great app with great features. Also, once again, you put your heart, your soul, your work into it, and suddenly, like a shadowy figure emerges from a corner of the room, and get this. It accuses you of stealing the concept of scrolling. Yes, scrolling. It's like a silly accusation, but welcome to the world of patents where actually patent trolls exist. And they would accuse you of silly claims like that, and they will rake on legal fees, and they would also stop innovation. Also, I don't know if you remember, but like 10 or, I don't know, 15 years ago, there was a really cool feature. It was cool at the time. I think it's cool still. The one that is swipe to unlock. Probably all of you remember this feature. And a company called ZeroClick actually claimed that they've invented the feature, although they did not. And they sued companies like Apple for millions of dollars. And of course, this accusation was wrong, and everybody knew it, but still, it had to go through all of the legal procedures to prove it. So it's really annoying. And what to do, how to ensure that, that patent trolls don't come after you. So the one thing that you can do, actually, is to have a robust portfolio. Like a portfolio like Nord's. Let's put it that way. Let's be proud of our portfolio. It's basically the best offense, like the best defense, I would say, in the tech world would be a good offense. So at this point, it would be a good and strong portfolio. And I will have a sip of water if you'll let me, because my mouth is dry, and then we will proceed. Right. Okay, so let's move to the fun part, which is Nord patents. And it's the part where you all actually contributed as well, because we have a lot of inventors in our company that you probably haven't heard about, but I cannot name you the names, but you can guess on the technologies I will mention. So, okay, to start with, cyberspace in general has more than 300 US patents granted, which is a huge number, to be honest. And we achieved this number all over 3 years. So that means that we are going, our speed is basically 100 patents per year, which is like a fast speed, I would say, for a company like ours, because we're comparably young. And also, the other thing that you probably didn't know or haven't heard before is that we hold the highest amount of patents within the Baltic states as well in the US. So, okay, despite from that, cyberspace, when I mention cyberspace or just Nord in general, I mean Nord Security, I mean Surfshark, I mean Atlas VPN as well. So as talking about Nord, Nord has more than 260 patents granted in general, and we still have 150 patent applications pending. And to make it more interesting for you and to make the numbers clearer and everything, NordVPN actually holds the most patents, to be honest, and thanks to our collaborators from teams like from infrastructure development, threat protection teams, and then after NordVPN, we have NordPass with more than 50 patents, and then we also have NordLayer and Surfshark with 10 and 12 patents respectively. Okay, so the technology we've patented. So basically, this corresponds to the technology that that you've worked on for the past 3 years, or even not for the past 3 years, even earlier than that. And these actually are the technologies that we hold the most patents on, I would say, at the moment. So the first one, of course, is the MeshNet implementation, and it lets us to connect our devices securely in like everywhere in the world as well. And we have envelope encryption. Then we also have authentication innovations where we use some kind of not older, but more known methods like TOTP, and we combine them together with passwordless or biometric solutions to enhance it. And then we have VPN developments together with diskless infrastructure, or even multi-hop. Also, we have some not implementations, but like optimization of protocols like NordLynx, or optimization of radius as well. And then we also have, not a lot, but quite a significant amount of patents that relate to ML model, that relate to machine learning models for detecting the malware. And it's just a small part of the topics that we actually touched at the moment. We have way more, and you can see it in the slide. Some of them are not even visible. And these numbers are changing yearly, so if you would ask me about it like within a year or so, the topics would be different probably. Okay. So when you already have a patent and you have your place under the patent sun, you're just happy. So let's say we have that with Nord. What happens then? What happens to competitors that are trying to have their ideas verified by the patent office as well? And what happens to them when they try to verify the ideas that are super similar to ours? Well, they get not denied, but they have to offend their ideas, because if their ideas are similar to ours and the patent office recognizes it, they have to cite Nord patents, to be honest. And by citing our patents, that means that their ideas are similar and that our ideas are actually valuable at this point. So firstly, our most cited patent is the one from Surfshark, and it has been cited 32 times in general. And it has been cited by companies like VMware, Fortinet, and Forcepoint. And if I'm correct, Forcepoint has like Forcepoint or Fortinet, I forgot right now, but they have like more than 2,000 patents granted in US. And that means that their portfolio is basically 10 times bigger than ours. And the idea that they're citing is it provides resilient VPN connections by offering multiple encrypted tunnels and ensuring our network stability, to be honest. And in the second place, we have our NordVPN solutions, and we actually have 2 patents that relate to sticky streaming, and it has been cited 19 and 17 times, and our most, not valuable, but most legit citers are CatMyTech. It's a company, a startup from US, and our neighbors, of course, Oxy Labs. And in the 4th place, we have Atlas VPN with their idea of server picker. And it allows users to select VPN servers based on their specific criteria, protecting their server metadata. And this idea actually has been cited by Citrix, HP, and Cisco. And to be honest, HP and Cisco has more than 25,000 patents granted. So it's basically, I don't know, it's like hundred times more than ours. And if they're citing us, that means that we are working on the right direction and that our ideas are interesting to them as well. And the last but not the least, we have a Surfshark patent of multi-hop solution, and it reroutes traffic through different VPN servers without losing the user session and adapting the user requests. And this patent has also been cited by HP, Citrix, privacyrating.com, and etc. Also, the etc. part doesn't mean that there's anything waiting after it, because a lot of universities actually are citing our ideas as well. So, and this is also like only 5 patents that I've mentioned out of like 305 or 306 right now, because the number is constantly changing. So imagine after a year, our patents will be cited like 10 times more. So our portfolio will be worth 10 times more probably as well. Okay, and to close my presentation, we should answer the question, why do we actually need patents at Nord, or why do we need patents in general? So firstly, patents act as a legal shield for innovative technology. So as I mentioned before, it gives us exclusive rights for 20 years into our technology, so it protects the investment, and it makes our research and development actually legit. Secondly, it deters the litigation from trolls and other competitors. And finally, patents demonstrate our commitment to innovation in general. And they signal to investors and the public that we're constantly pushing and trying to find and do something new in cybersecurity. And once again, I would like to ask you to collaborate with us, actually, because we do that constantly with people that we already know. We try to encourage new teams to come to us. So one way how you can collaborate with us is just to write us a message. If you have some kind of novel idea, or you think that you have a grip of an idea, you can come to us. You can write us a Slack message, or just open our Inventors Hub and fill a form there. On the other side, we also ask you people to partner up with us. If you want to do some collaborative research project, we're also open to new possibilities. So please contact with us, and I hope you had fun, as I did, and you're less nervous than I am right now. So thank you so much for your attention, and that's it.
So, who wants to be an inventor? Do we have any hands in the audience? Yeah,
no.
I see now how it's going with you when you are trying to sell this pitch. Okay, maybe we have some questions though about the patents.
No, everybody knows everything.
Great presentation though. Now Paul as always has a question. Whatever
He's an
it is.
inventor as well.
Yeah, I know. So maybe that's gonna be the question about it. I don't know. Yep.
Okay, so it's maybe gonna be a more of a political question.
Shoot.
But do you think that the current time frame, I think it's 35 years for a patent to expire in tech
It's
place?
20.
20,
Yeah.
yeah. Is it like too long or too short? And is it always good to have like long patents for like creativity? Because after for example, the 3D printing technology's patents expired, then there was a huge explosion of like multiple inventions and so on. So it feels that sometimes it can be detrimental to creativity and invention of new things. So
True, you have a point, but well, when we feel like the patent is not useful anymore, what do we do in our patent department? We just abandon the family. We close the family, so we do not file anything new. We do not keep it alive. And if you really want to share your ideas with others, just like do an open source, like we did with MeshNet. Just let people use your idea. Why not? Well, of course, you will have to license it as well, but you will be able to use it. And I think that 20 years is a perfect amount of time at this point. And I think it depends on what you're working on, actually. In tech, maybe it's too long because the tech is constantly evolving and changing. But when you see like other fields like biotech or whatsoever, like medicine, maybe it's enough. I don't know, maybe we would need more or even less. It depends.
I guess I have a bias for technical things,
Yeah.
and 20 years feels like a lot.
Feels like a lot, yeah, feels like a lifetime, I understand.
Yep, thank you.
Okay, any other questions from the audience?
No.
No, we have one from Slack though. Wait,
Oh, no.
wait a minute. So Yanis is asking, isn't patents actually limiting innovation? So this is kind of reflecting the Paul's state of mind.
Well, at the same point, it does both, actually. It actually makes you think more creative, to be honest. Because one way is patented and you cannot use it, you have to figure out a creative way how to go around. So you create another new technology that works maybe even better and maybe even simpler. And maybe you're a genius at this point then.
Nice, I like that. Okay, and the other one from Yanis as well.
Oh my God, Yanis.
Yanis loved the topic. So he's talking a lot about an mRNA and COVID and so on, but in the end he's asking, would it make more sense to not patent certain things so humanity can benefit, like ethical patenting? Is there any discussions
I have
about that?
actually never heard of it, but I don't know that in tech there's such topics like ethical patenting. I think there should be one in medicine that would benefit people in common, you know, like for insulin or etc. You know, that would benefit the humanity in general. But in tech, I don't know. Should there be one? No.
Okay, you did great. Thank you very much for presentation. Okay, the last bit, and the special guest that we have today, I don't know if you know, but he's a cybersecurity expert and advisor to Nord Security as well. And he's going to talk about wooden sticks and how to hide in plain sight and everything. So, welcome on the stage, Adrianos.
Does the microphone work? Yeah, it works. Sorry, I need to get my wooden sticks out of... because I really brought them, and they kind of survived the travel. We'll get back to these in a bit, because I actually made something. All right. Welcome. Hi. First, I always do disclaimers, but this is just a generic thing I always do with every presentation. First one is, I am not a lawyer. I talk in a lot of countries, and I say a lot of things, and sometimes things that I say or encourage people to do are not legal. So please, 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 in this case, it won't be that bad, but please always consult a lawyer or know your local laws. Second one is also important, especially with technical people for some reason. I'm not always right. I know this. I talk about what I think I know, from the context I know, and from the things that I've learned from other people, but I might be wrong. So feel free to correct me, but please after my talk. The third one is, your mileage may vary. I do the things and I talk about these things, how I experience them, how I work with them, and how they work for me. It doesn't mean it's a one-on-one copy for you. And of course, I'm an 80s kid. You can see by my gray beard, I'm old. So my pronoun game is not very strong, but I love everybody, whatever your pronoun is and however you want to be called. But whenever I say he or she, please hear the pronoun that you feel comfortable with. So let's first start with, what is parkour communication? Parkour communication, I started this in 2017 at the SHA 2017. SHA is one of the hacker conferences that's every 4 years. It's really big. It's one of the biggest in Europe. And it's intense, and it's in Biddinghuizen in the Netherlands. And I gave a presentation on parkour communication. The QR code, normally I advise against QR code, especially when I'm in interviews for Nord. But this one is really safe. I made it myself. It's not rigrolling, it's not malicious. It's just a link to the YouTube video. But if you don't trust me, just go to media.ccc.de and Google and search for parkour communication. This is the original presentation. Parkour communication is basically communication without building anything new on the internet. And I'm going to explain in this talk a bit about how you can do this, why it's possible to do this with everything we've got. And it's also possible for non-technical people. So, why would we want to do this? It's simply because sometimes you need to have fun, that's one part. But the other part is, if you're in a country where you have an oppressive regime, or there's some other groups that are watching you and that they have technical skills, you might want to get a message from someone to someone else without having correlation, without them knowing that the message is actually sent. This is my main reason for parkour communication. TechBro said, encryption is invincible, and TechBro is not wrong. But there's a trail, and encryption also leaves other artifacts which can be analyzed and which can be brought back to you as evidence. So encryption is not really an option in this stage. Steganographic encoding in 12 packets, blah, 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 blah. Yeah, that also works, but I want to have journalists or random people or just oppressed people who are afraid to be able to use these kind of techniques as well. And I don't want them to download all the kernel headers from Linux and the build tools and then figure out how to finally make something. They just need to be able to use it. So, the first thing we need to do is to understand the 0 and the 1, because they're the atoms in computing. Everything you see on the screen, everything you hear, everything that goes through these streams, everything is encoded in zeros and ones. The zeros and ones, I will explain it to you, is because it was easy to measure in the old days of computing. Something having a voltage or near a maximum voltage and something having no voltage, like power on it, was easy to measure. Nowadays, we still do that, but in things like SSDs, there's a whole lot of stuff going on with multiple voltages and error correction, and you don't want to know. It's much more fun to have an LSD trip and watch one of the horror movies. Really. These zeros and ones are really the basic component of what we are going to use. And once we have zeros and ones, these atoms, we can make bytes out of them. And when we have bytes, we can make longer sequences, and we can make other characters and other stuff out of it. We can make pixels and images. So the zeros and ones are really essential to parkour communication. This is a simple diagram of the letter S in ASCII. And as you can see, you can encode it in zeros and ones, as long as you have a sequence, a place for the 0 and 1, and you give it a value. So that's plain and simple. Everybody who does anything with computing probably knows all of these things and probably can remouse those numbers up until like a million or something, or 4 billion, I don't know. So once we have those bits, once we understand that we have bits, we want to give them from one person or one place to another place. And if we just start throwing bits from one side to the other side, that will not work. So we need to have a protocol. What is a protocol? A protocol is basically an agreed way of doing something. So let's say, for instance, for internet, we would say that the first few bits are saying this is a Ethernet, this is an IP packet, then the next few bits are the addressing. So we have this protocol. And I'm saying this wrong because the protocol is also about how you get something from a server. Let's say for HTTP, if I request a web page, it says you have to start with a verb like get, put, delete, whatever, then a URL, a path, and then the protocol version. And then, of course, some headers. That's a protocol, so we agree to something. Then finally, when we move those bits over to the other side, it might be an image, it might be a sound file. So we have to know how are these bits arranged, and that's a format. So when we have a GIF, sorry, I've been corrected this week. When we have a GIF, then basically it says GIF 87 and then the rest of the stuff. And then, of course, we can also use encryption. And encryption is basically messing up the whole format or the protocol, but in a way that it's reversible and in a way that somebody cannot easily guess from the outside how it was reversed or in what manner. That's basically one of the things that we use to move around bits. But if I just want to say hello in my, this is, by the way, an AI version of Lionel Richie for the older people. If I just want to say hello, I can devise my own protocol. And browsers and chat apps, video apps, well, they also have their own protocols. So a browser has this text-based, line-based protocol. A lot of chat apps have things with channels and users. Video apps have, again, with streams and what kind of streaming format and protocols they have. And of course, VPNs have their own protocols and way. That's something you should all know about. So the protocols, they're good for productivity because once we have a protocol published somewhere, everybody else can take that protocol like HTTP or HTML, and they can just make something with it and it works in somebody else's product. This is the whole idea of those protocols. And those protocols, a lot of them are really well described in something called RFCs, request for comments, which are actually the internet standards. But again, because it's really well described and everybody does it in the same way, protocols are also really well for snooping or automated detection. Because, apologies, if something is out of the ordinary, you can quickly detect it. And machines, because of those protocols, know exactly where each piece of data is, can also quickly sift through it, and with machine learning, you can quickly find out where something is. This is, in fact, the whole basis for the machine learning threat detection or malware detection. You can also use it for data mining. So protocols are nice, good for productivity, but they give a lot of correlation. If I send a request to a website and I get a response, I have a correlation between me and that web server. If I send a message via WhatsApp or Signal, there's a correlation between me and the recipient because of the keys, not because of the bytes that are being sent, because they're being sent to a server and then from the server to the other client, but because of the private public keys for the encryption that we use. So there's always a correlation. And as I said, there's lots and lots of correlation. These are just a couple of examples, but there's way more. If you're an incident responder or if you're anywhere in the threat hunting teams, then you know all of these and you know that there's a ton more than this. We have server logs, we have audit trails. Audit trails are somebody logged in, somebody did this, somebody did that. We have routing information. If I send a packet, an IP packet to somewhere, it has routing information, so there's a correlation between me and the other side. And also, my machine does DNS requests, name server requests. So again, there's a correlation between me and the site that I have. I'm going to speed it up a bit. Let's see, yeah. All right. I've got 9 minutes for the sticks. First thing, this title is of course just for fun, because of course I cannot beat quantum decryption with sticks, because I don't even know what the hell quantum decryption is. Yeah, I know about Shor's algorithm, but I haven't seen it in practice. I haven't seen them breaking keys en masse. So, but it is something that you really should understand, is that it doesn't matter how powerful the method of decryption is for the other side. If they have nothing to decrypt, it's game over. And this is basically what we're trying. So I tried for myself a challenge. Can I do something which is completely non-electrical, and I can do a mass copy? And the last part is important, because of course you can do something non-electrical, because you just take a piece of paper and you write something on it. That's easy. But I want to have a mass copy, and I want to have it being digital. So I started for myself a challenge. And it's also to make a point, because my solution does not have to be the solution. In fact, I don't really want it not to be the solution of everybody else. My solution is just one of the ways possible by just thinking of a lot of things in bits and bytes. It was also a ton of work, and never ever again, because nobody in his right mind would want to do it like this. But I hope you get the smarter ideas from this, and you can help people, especially journalists, because that's also something we do with Nord. We talk to journalist organizations and try to help them. So, I first try to draw it out. Who thinks this is clear? Yeah, nobody, not even me. So I first started drawing, thought, nah, this doesn't work. So let's just sit at it and we'll see what happens. So these are the tools I allowed for myself. Just like €3 worth of sticks. And of course, I did something really stupid. I bought the cheapest sticks, which are uneven. And that's not fun, because as you will see, all the little bits, they should all be the same size, and it wasn't. Also, I used a handsaw, which is also not a good idea, but and some rubber bands and some wood glue. So, if you look at it, all these things, all these small squares, they're individual bits, which I can move up and down. And they are not held in place at all, so they fall down back again. And what you do is you use the rubber bands, I'll show it in a minute, to clamp them down. So you can see, if you use the rubber bands, I have bits which are on or off. And what I can do with this little wooden thing is I can just put another one on top of it, which has no rubber bands, and it is immediately a copy. And I can put another one on top of it, another one. So I can do a mass copy really quickly of these wooden sticks. And just as soon as I put one on, rubber bands, next. So I can do mass copy of my message. I can do a couple of hundred in a few minutes. So this is basically what you do with the rubber sticks. And I'll show it that it's real and not an AI image in a bit. But this is just my solution. And as I said, don't just use the internet fixtures. You can use everything. First I wanted to ask the marketing team to buy me 100 rolls of black toilet paper, but then I saw how expensive it was and then thought, nah, let's not do that. I did that experiment, by the way, in reality. QR codes just in the window with toilet roll papers, because you can buy black toilet paper and you have white toilet paper, and then you can just stack them in any form you want. I gave marketing team black memo cards, so I really hope they will do something with it later this week. And of course, everything that you decide is a 0 or a 1, can be a 0 or a 1. I heard we're going to the gym at Sparta in a bit. So an empty beer glass can be a 0, and a full one can be a 1. Only problem is, of course, everything devolves to 0 at some point. But it could be. But also, you can have things like on X or Twitter, if you put a message in there, you have a normal message. If the first word has a P in it, then it's a 1. If it doesn't have a P in it, then it's a 0. And in this way, a journalist in an oppressed country can give an interview and have all nice words, all correct words, but still send a message through that channel to his home base, because I'm making lots of fun out of this, and it is a lot of fun thinking about all of these things, but it has some serious applications as well. And this is something you really should realize, that digital 1 and 0, that's the really big invention that we actually have. All the other stuff is really fun and really cool, like the mobile phones and everything, but it all follows from how we, and this is on your mobile phone, it's really awesome with quantum tunneling and stuff in your chips, but how we can move around zeros and ones. And once you grasp that idea, you understand that, oh wait, I don't need the internet, I don't need anything digital, I can communicate in any way that's already existing. And as long as the other side that is trusted with me knows our protocol and our format, they can receive the message. I can hide it within something. And of course, there's things like steganography and all those kind of things, but they're also detectable. And again, they're electronic. So that's it. I was even speeding up this time. I will show you, I have 3 minutes left, so I can show you the sticks a bit. And just to show that it's really loose, I hated doing this, but I can just pull all of these out. And I had to make 400 of these. And making the 400 is not a problem. Putting them all in, that's the problem, especially if you don't have, if you have uneven sticks. And if you have that, the bigger problem is, of course, 400 bits. What can you do with that? That's what I've been asked a couple of times. Well, 400 bits, it's 50 bytes. And that means I can put a latitude in there, 8 bytes, longitude, 8 bytes, and an exact, really exact time, again, 8 bytes. And then I have still space for a message. And I didn't do this because of time shortage, but I wanted to encode the message like the location of this, like the Sparta bar and the time for the end of today. But that easily fits into 400 bits. And of course, somebody with a 3D printer can make a really nicer version, a really smaller version, but this is not suited for any purpose at all. It's just to prove a point that it is possible. And I want you all to think, I don't want you all to think, but I would like you all to think about things, how you can communicate in these ways, and also help sometimes journalists and other people in countries where communication is really difficult. Because Nord is really working hard in some countries, but sometimes the law wins. And it means that sometimes people need other means of communication securely and safely without their government being able to touch them. All right, now I'm closer to the ending time.
Thank you, Adrianus. So do you use this with your friends? Like, do you communicate with this within sticks? What's happening here?
No, I'm mostly using Signal, and this is for me to get really into like this cursing mode when I have to put in all the bits again. So
Okay. I remember one really cool RFC about it as well. It's like 114945. It's about the pigeons and sending the message.
Yes, that's TCP over avians, and some people actually did it.
Really?
Yes, you can find it on Wikipedia. They used TCP communication and they used carrier pigeons just to prove a point that the TCP protocol is robust against a lot of loss and delay.
Okay, guys. Do you have any questions from the audience, though? Paulus, I'm looking at you because you usually have a question. Emu? Yeah, you have one? Okay, let's try. Opa!
Okay, why sticks? Because you could try screen printing or silkography.
The sticks were really just a whim, and I had in my mind this title of quantum cryptography and sticks, and it just meshed really nice. Otherwise, I would have fired up my 3D printer to do it again, but this was just, it looked better, like the real wood against this powerful quantum thing. That was all.
Yeah, makes sense.
Okay, any other questions? Paulie.
But is it really secure? I mean, like, would it be that hard for me to just look into that thing and decode it in, like, let's say, a couple of days?
I hoped I didn't have to do this, but there's plausible deniability built in as soon as you come at me.
Okay, understood. It's very thermal. But in that sense, beers are safer.
Yeah, there's lots of ways to do this safer, but
Thank you.
I knew somebody would ask that, and I hoped I didn't have to pick them all up.
We're gonna help you. We're gonna help you. Okay, Jakub.
Okay, you've probably heard about the debacle when Edward Snowden tried to share his PGP keys with the journalists deleting security.
Yes.
Do you think it would be feasible to equip all the journalists with wooden sticks?
Yes, but you probably would need either 10 of those or like this big wooden board. And that's kind of conspicuous when you're walking like... So it would be a bit cartoonish, but I think you can use parkour communications to share public keys. And I don't want to tell you too much about this because it might be in use, but you can use it to share public keys in different ways and across media that is hostile.
Yeah, that actually makes sense. Thanks.
Okay. Anyone else? Emo again. Okay. We're gonna have a discussion, looks like, with the beers.
Have you tried making QR codes from the sticks?
Yes, but that was my original intention, but then I found out that QR codes have a minimum size, and I already was sewing stuff. So yeah, absolutely, it can be done, but then you would need a little bit bigger board.
Great idea for patenting, right, Agne? Yeah. Okay, I think we're gonna close this. Thank you, Adrianos, very much.
All right.
Okay, so that's a wrap. What I would like to say, the last bit, is thank you for Monica. I don't know if you are online and watching, for the whole design and how professional this event is starting to look. Then, for the filming and streaming crew from Mobile Media, can we have an applause? Yeah, Eimantas Rokas, Ignas Augis, and of course the one and only Evelina, where are you? Yes, honestly, she did everything. I'm just here on stage to have fun, but the whole organization and stuff is done by her. Thank you very much. I hope to see you in winter session. Maybe we're gonna open the event as well. We're gonna see how it will go, but I know that a lot of other companies gonna join, that's for sure. So whole NordSec and maybe Teso Global, we're gonna see how it will go. Thank you guys, it was a pleasure today. Let's meet up in Sparta. Ciao!